when it comes to like CCIE or CCNP CCIE switching is officially like, there is no dedicated certification for switching. So when it comes to like CCNP or CCIE switching content, it is part of like CCNP Encore exam, and it is part of CCIE Enterprise Infrastructure Lab exam. Switching is there, there is no dedicated certification for the switching, but switching is actually part of like the Encore exam, and the switching is part of like Enterprise Infrastructure Lab exam. You can always expect like a few questions, at least 1 or 2 sections like for the switching, and then like multiple choice questions like in the Encore exam. So let's first go through the content. This is the entire switching that we have currently in our syllabus, and we are going to cover this entire switching part. Like everyone who is preparing for the Encore exam, everyone who is preparing for the Enterprise Infrastructure Lab exam, for both the candidates, like this content is going to be enough. This content is going to be sufficient, right, to attempt the exam. Let's see first like the content, and then we will go through the classes. So if you search like CCNP Encore, right, you search like this CCNP Encore. Here you can go for like the first link here, or you can just directly click on the exam topics from here, so that you get the idea what content we are going to cover. So in the CCNP Encore, we have a very little bit part of the switching, and then we have some. So see the version 1.1, like earlier it was like 1.0, and now it is 1.1. So officially from 20th September, the content has been revised. Only 20% of it has been changed, like not a lot of content has changed. So 20% like here and there, some topics they have added, some topics they have removed. So the current the switching content that we are going to cover is going to be based on Encore version 1.1, right? So here is the entire Encore curriculum. Like in the entire Encore curriculum, we have architecture, virtualization, infrastructure, assurance, security, and automation. The entire like Encore exam, which is more like the written exam for CCIE Lab, also the exam for the CCNP. Like Encore is common for both CCIE and CCNP. So if you want to be a CCNP certified, then you have to take this Encore exam and then pass any concentration exam to become CCNP. And if you want to become CCIE, then also you need to go through this Encore. You need to take the Encore exam, and then you can like attempt the like this lab exam, right? So officially in the Encore exam that we have, in Encore exam we have total 6 parts, total 6 I would say topics are there, and these 6 topics are like architecture, virtualization, infrastructure, network assurance, security, and automation. So anyone who is willing to attempt the Encore exam must actually go through like these topics. And in the architecture itself, we are going to have this switching part. So if you click on this architecture here, explain the different design principle used in the enterprise network, basically like layer 2 design, layer 3 design, fabric, cloud, like so high level enterprise network design such as 2-tier, such as 3-tier, fabric, cloud, and all that. So that is one thing we need to cover. Then we have HA, high availability techniques such as redundancy, first hop redundancy protocol, and stateful switchover, SSO. So these are 2 topics from the switching exam, right? These are 2 things from the switching. So this is we will cover as a part of our content. Then scroll down, then we have here wireless, a little bit of wireless from the wireless design point of view. So when you cover the wireless, then we will talk about these content, like what is wireless, how to connect like access point and all those things. So this is there. Then we have SD-WAN SDA solution. SD-WAN SDA, like there are, I would say, 2 pages of the SD-WAN, 2 pages of the SDA in your Encore book. So you don't need to know like in very detail of the SD-WAN or SDA in the Encore exam. This is just more like the introduction to like SD-WAN solution and introduction to like the SDA solution. No need to worry about that. Quality of service, again, this is part of CCIE. Anyone who is attempting CCNP must also be aware of quality of service configuration. As you can see, nothing from here to here is switching. Like it is like wireless, it is like SD-WAN, SDA, those things. So this is the only part that we have for switching. And then we have this hardware, software switching methods such as CEF, CAM, TCAM, FAB, RIB. Like this is also part of switching. So 3 things we will cover from here: 1.1 and 1.6. This is part of switching. Okay, rest no need to worry about. Then go to the virtualization. In the Encore, we have concepts of virtualization where we should know what is a server, what is server operating system, what is a hypervisor, virtual machines. So this is again some virtualization techniques based on server. And in routers and switches, especially if we talk about like routers, we also have a virtualization technique that is referred to as VRF. VRF is basically like virtual routing and forwarding. VRF basically allows you to create like multiple router instances within the same router. Like if this is one router, in that router I can configure multiple routing instances. So this is like one VRF, this is like second VRF, third VRF. A VRF is basically, VLAN. Just like with the help of VLAN, we can perform segmentation at layer 2. Similar to that, like with the help of VRF, we can configure like different routers, logical routers within the same router. So two interfaces, one VRF, two interface, one VRF, two interface, one VRF, two interface, one VRF. They will communicate, they will communicate, they will communicate, they will communicate, but they will not be each other, just like we have in the VLAN. So VRF is a concept that we cover in the routing section, not in the switching section. After that, we will talk about like this GRE, IPsec tunneling. This is also one thing like GRE and IPsec. GRE and IPsec is also like part of this virtualization concept. So how can we configure tunnels like, based on GRE, tunnels based on IPsec, then we have Lisp, VXLAN. So this is also like, these all are part of the virtualization technique. So when you cover like CCIE or when we cover like SDA and SDA, then we will talk about like these technologies. Again, no switching here. There's no switching content here. Then go to the infrastructure. Right here we have the layer 2 and that's all that you should know. This is the layer 2. The only thing that we should know from the switching point of view is this. You should know troubleshoot static and dynamic .1q trunking. So basically you should know what is trunk, how can we configure trunk between the switches. Then you should know the ether channel. Then you should know the spanning tree protocol, STP, RSTP, MSTP, and STP enhancement feature such as root guard, BPDU filter, basically the additional features that we have in the spanning tree protocol. And that's it. That's pretty much it. From the content point of view, this is max, this is all that we have to join. Like this is all that we have to cover. In the Encore, from the switching point of view, that's all that we have to cover. Okay. Then layer 3, routing, no need to worry about it. Then wireless, no need to worry about it because it is part of Encore. Then IP services. In IP services, we have NAT, PAT, here HSRP and VRRP. We do not have GLVP. We don't have GLVP now. Earlier we had like GLVP as well, but we are now only going to cover HSRP and VRRP. Right, so these two things, first stop redundancy protocol, we will cover as a part of our switching curriculum. So configure first stop redundancy protocol such as HSRP and VRRP. We don't have GLVP protocol now. They have removed GLVP. Right, PIM, IGMP is part of CCIE, so no need to worry about it. So this is one thing that we are going to cover from the switching point of view. Network assurance, here. Span, RSPAN, ERSPAN. This is part of switching. We will cover this as a part of our switching content. Right, you can see that the content in the Encore is here and there. Like switching content is, some content is here, some content is there. So we will talk about the span, RSPAN, and these things as a part of our switching content. Security. Security, we are going to talk about what we are going to talk about from the security point of view. That is in CCIE, SDA. So here we have some layer 2 security features which are not mentioned here. When we see the content of CCIE in a moment, we will see. So we will cover a little bit of the security part as well, but not this security, not these things. Right? We are not going to talk about these things as a part of switching. We will talk about like some layer 2 security features, DHCP snooping, dynamic ARP inspection, those things, but these are not mentioned here.
Yeah, what is that a 4-way handshake that EAP
over L, this is extensible authentication protocol over LAN. This is basically like when we enable .1x, EAP protocol is being used. So the four-way handshake, basically how EAP works actually. That is part of security. So when we cover the security, then we will talk about it. So this is like there are 2 chapters in the ENCORE exam that completely focus on security, and those 2 chapters have in total approximately 120 slides. Those 2 chapters. Every product that we have in security, they want you to know about it, at least in the theory. So if anyone is attempting for the ENCORE exam, they must be aware of like all the security products, WSA, ESA, ICE, AAA, and all. We'll see just in a moment. We will see. So this is covered in there. Right, so no switching here, and automation programming, no switching here. So there is a very limited amount of switching content that we have to cover from our ENCORE. Right, so just like 1.1 we are going to cover, then 1.6 we can cover, we will cover, then we will talk about like scroll down, layer 2 switching right from here, then we will talk about FHRP, HSRP, VRRP, GLBP, then we will talk about SPAN, RSPAN, and that's pretty much it. This is all that we need to know from the ENCORE switching point of view. But if you go through like the CCIE switching point of view, from the CCIE switching, because this content that we are going to deliver, that we are going to cover, it is going to be like both CCNP and CCIE, right? So the entire switching will be done. You will not require any more switching classes after this content, not for CCNP, not for CCIE. This is entire switching, whatever is left in our content. So if I cover like CCIE, if I search like CCIE Enterprise Infrastructure Lab exam, if I search CCIE Enterprise Infrastructure Lab exam, if I click on this first link, so here is the CCIE Enterprise Infrastructure Lab exam version 1.1, because earlier it was 1.0 and they have changed the 20% of it, and then like this is now 1.1. This is what we will cover. So again, this content is divided into 5 parts. The part that we need to focus on is just this one, just the network infrastructure. So if I expand it, right here we have very first topic, switched campus. In the switched campus, we have switch administration, such as managing the MAC address table, error disable recovery, MTU, layer 2 protocols such as CDP, LLDP, UDLD. Then we have VLAN, we have Ether channel, we have spanning tree protocol. So what is access port, what is trunk port, what is native VLAN, then voice VLAN, whatever, regarding whatever things we have regarding VLAN here. Then we have Ether channel like LACP, PAGP, whatever concepts are there. Ether channel load balancing, layer 2 Ether channel, layer 3 Ether channel, multi-chassis Ether channel. Right, we will identify the multi-chassis Ether channel use case. No need to configure it. Just understand what is multi-chassis Ether channel. Remember, whatever says describe. Whatever says troubleshoot, configure and troubleshoot both. Yeah. So they have like LACP and static. They do not have PAGP. So port aggregation protocol anyway, like it was proprietary, Cisco. LACP is open standard. Link aggregation protocol, it is a technique to perform link bundling, and it is open standard. PAGP was also a protocol that was proprietary to Cisco. So they have removed like proprietary protocol from there. And where is like in here DTP? DTP, like managing MAC triple error, CDP, LLDP. Okay. They have removed DTP as well. Right. So DTP is no longer there. VTP, where is VTP? Where? We don't have VTP as well. VTP they have also removed. There is no VTP now. There is no DTP now. So VTP they have also removed, and the reason remains the same. Why they are limiting down the content? Because we are not going to use layer 2 access layer anymore. Things are moving towards software defined networking, and the software defined networking, everything is layer 3. So switching, exactly, like we can build our logical tunnels and everything. So since they are moving from the legacy switching campus to the SDA switching campus, software defined campus, so they have basically removed quite a lot of content from it, right? Such as, for example, they have removed VTP, they have removed DTP. Later on, you will see. Basically, you can think that all the proprietary protocols that they had, ISL they have removed completely. You no need to study about ISL. They have removed like DTP, they have removed like VTP, they have removed like GLBP, right? So all the proprietary protocol that they had looks like they are slowly removing those protocols. Right, so this is loop guard, root guard, port fast, these things are still there, but this is switched campus. See, 30%, okay, this is 30%, and 30%, just see 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.6 is there. So 30% content, total 6 parts. If I divide 5%, so this is 5%. This is 5% in your exam. Just 5% of switching here. And now you can, of course, like when as our course progresses, we will talk about like what type of questions they have asked in the previous exam regarding this switching. So you will get the idea how much you should cover from the content point of view, such as so that you can attempt the lab exam, so that you can attempt the NCORE exam, right? So just understand this is 5% of the entire content. Okay, so this is what we will cover as a part of our content, or as a part of our updated content. So this is version 1.1. This is what we will cover. Then we have like here in the routed in the switched camp in this network infrastructure, we have switched campus. Then we have like routing concepts. We have EIGRP. We have OSPF. We have like BGP. This thing is, we will discuss when we start our routing class. Maybe after the switching, when we start the routing, we will discuss about this, right? Then multicast and all that. Forget about it. So this is like 5% content that we will talk about like from here. And then software defined infrastructure, we have SDA and SD-WAN. Again, we will talk about this when we have our SD-WAN, SDA classes, right? So no need to worry about this. A transport technology and solution has no topic of switching. So no need to worry about this as well. This is part of routing. Then if you go to this topic called automation, like infrastructure automation and programming, it also has no topic of switching. So no need to worry about this topic either. Here we have some switching concepts. So if you go through security and services, here we have a few security related concepts such as control plane protection, control plane policing and protection. This is one feature that we will talk about as a part of our switching content. A AAA we can also talk about. Then here, switch security feature, VLAN access list, port based access list, storm control, DHCP snooping, IP source guard, dynamic ARP inspection. Like these are the features that we enable on the switches. These are the features that we will enable on the switches regarding security. Then we have some router security features. Again, no need to worry about, because this is from the router point of view. Then we have IPv. This we will cover in the switching. Why? Because these features are applied on switches, not on the router. So IPv6 infrastructure security features, these are actually switching features. These are the features that we apply on the switches, not on the router. Features such as RA guard, DHCP guard, binding table, and device tracking, and all those things. These are the features that we actually apply on the switches, not on the routers. So we will talk about like what is this RA guard, all these things we will talk about as a part of our content. Then, yeah, no switching here. No switching here. First hop redundancy protocol. We have HSRP and VRRP only. They have removed GLBP. So we will no longer talk about gateway load balancing protocol. Anyway, like GLBP is a little bit complex to understand, and GLBP, I have personally not seen GLBP like in a lot of production environment. Like I don't recall actually seeing like GLBP in any production environment. Like no one has reported that they are using GLBP instead of HSRP or VRRP. A few like a few like companies might still use it, but other than that, like mostly companies, they rely on HSRP or VRRP. And since things are moving towards the SDA anyway, we will not require any HSRP or VRRP, which we will discuss in our SDA classes. Right, and then how can we have the redundancy based on IPv6? So like if we have deployed IPv6, you actually don't even need HSRP, VRRP, because IPv6 itself has a few features that can provide you good redundancy. So we'll talk about that. Rest. So this is one thing that we will talk about from switching point of view. And span, RSpan, ERSpan, embedded packet capture. So this is we will talk about from the switching point of view. Yeah, that's it. So this is the entire content, like from this CCIE Enterprise content that we will talk about. And when this all switching class is done, like, once we are done with our switching class, then we will talk about some additional topics as well. Those additional topics are for CCIE Enterprise Infrastructure. So once the switching class is done, I will notify you guys that, okay, we are done with the switching class, right? Either you can like continue joining the class or you can leave, like, that's completely up to you. Because once the switching class is done, once all the content that we have discussed right now, once that content is done, then we will talk about some additional content such as we will talk about this router security feature. We will talk about like SNMP. We will talk about syslog. We will talk about like NTP. We will talk about like DHCP. Like these are all the small topics, additional topics, which are neither part of routing nor part of switching. We will talk about those topics at the very end of our switching curriculum. So like these SLA, like, tracking, embedded packet capture, like we can do the packet capture within the iOS XE device nowadays. And then we can download that file and then we can analyze it with the help of Wireshark. So all these small tools, all these small topics that we have, which are neither part of routing nor part of switching. Once switching classes are done, then we will talk about these additional features as well. And it's completely your choice if you want to join those classes. It will be like 2-3 more classes after that. So switching class, once it is done, then we will talk about in like I would say in 1 week maximum, like in 4 days maximum, we'll talk about all these additional classes. So anyone who is attempting, who is going to take the CCIE Enterprise Lab exam, or anyone who is preparing for that enterprise infrastructure content must join those classes, right? So switching will officially end in 18-20 classes maximum. It will not take more than that, maximum to maximum. Earlier it took like 20 to 23 classes maximum. Since we don't have VTP, since we don't have DTP, we don't have GLVP, we don't have like these additional protocols, it will take like 3 more, 2-3 more, like less classes actually. So we will officially cover the content in 18 to 20 classes maximum, right? So, and after that 3-4 classes we will talk about the additional topics that we have. Anyone who is attempting for the CCIE Enterprise must join those classes. We'll talk about in detail about NTP, SNMP, syslog, all those topics that are additional to our routing and switching content. Any topic that is not part of switching, that is not part of routing, we will cover after that. Right. Now you can download this in PDF. You can download this in PDF and keep it with you so that you have an idea what topics we have covered. And if any topic is left, then you are going to inform me that, okay, these topics we have still not covered. How you will study about these topics, what you can do, you can either download this book, this official book that you have from this school itself for the Encore curriculum. The official Encore book is enough for you to cover all the switching topics, right? So we have 2 books that you can cover from this entire content. So one, we have like the official Encore book, which is something like this. This book, like you can either download or get it from the portal, right? So this is one content that we will talk about. Here is the official like Encore book, Enterprise Core Exam, right? And if you go to this forwarding, if you go to here like layer, here you go to this layer 2. This is layer 2. So this is like, first we have spanning tree protocol, then we have advanced spanning tree, then we have multiple spanning tree, and then we have VLAN entrance. So we'll start from the VLAN entrance, then we will talk about like S3P, VTP, and all the other whatever topics are there in the content, then we will talk about. So chapter number 2, chapter number 3, chapter number 4, chapter number 5. In the Encore book, we have like these 4 chapters that you will cover from the switching point of view. Everything that is there in these chapters, we will cover as a part of our content. Right, then we have routing, no need to worry about it. Then we have services. In IP services, we have first hop redundancy protocol, FHRP. So HSRP and VRRP protocols we are going to cover from here. We also have, what is this? This is old book anyway. So this is like, it includes GLBP, but it is not global load balancing. It is gateway load balancing. Anyway, some typos here. Or since it is a Cisco protocol, maybe they have started calling it, who knows. It is gateway load balancing protocol actually. This is GLBP, Gateway Load Balancing Protocol. I have not heard it anyone calling like Global Load Balancing Protocol, but anyway. So they have given the content of GLBP here. If you want to cover it from your production point of view, maybe then you can cover it from here. But officially, as a part of our content, we are not going to discuss it. Right, then so IP services, FHRP, you will cover from here. What else? Architecture. Enterprise network architecture. This is design. So from the design point of view, here we will talk about like access layer, distribution layer, core layer, like 2-tier design, 3-tier design, that we have, 2-tier design, 3-tier design, like that we have. We will talk. This is chapter number 22 from the enterprise network content, enterprise network architecture, which focuses on how to design the hierarchical LAN model. 2-tier design, 3-tier design, access layer, core layer, distribution layer, and all that thing. Right, so you will cover it from there. Span, RSpan, Span, RSpan, and ERSpan. ERSpan is again not part of our content, but span technology that allows you to mirror one port to another so that all the traffic can be monitored. So span technology is in the network assurance section. Right, so that we will cover. And right here we have security. We have 2 chapters of security. One chapter, secure network access control, and one chapter is network device access control and infrastructure security. And if you just expand this right here, so next gen endpoint security, this is not part of our content. I'm just telling you that like after like routing is done, after the switching is done, then maybe you will have some dedicated classes for this security. So what they will cover there, what like in endpoint security, Cisco Talos, ThreadGrid, AMP, AnyConnect, Umbrella, WSA, ESA, NextGen IPS, NextGen Firewall, FMC, StealthWatch Enterprise, Cloud, ICE, everything. At least theory. You should know from the NCORE exam point of view, not the CCIE lab exam. The NCORE exam point of view, you should know like what are these different products that Cisco offers in security. Right, so you don't need to go through like in and out of like ICE, WSA, ESA, but at least you should know these solutions that Cisco offers and how these solutions are going to benefit your enterprise network. And after this, we have secure network access control. In the secure network access control, we have .1x, 802.2.1x, then EAP, MAB, WebAuth, central authentication with ICE, FlexAuth, IBNS, TrustSec, the tag propagation, SXP, propagation, enforcement. These are all the topics that we should know from the network access point of view. How when a device accesses the networks, how that device is going to be authenticated, authorized, and all that. Basically, AAA functions you should know from here. So if you click on this chapter actually starts from page number 708 and it ends on the page number 743. So like there are approximately there are like I would say like 40 pages that you have to go through from the security point of view, and this is one chapter. Then we have one more chapter. In this chapter we have like ACLs. In this chapter we have like AAA. We have zone-based firewall. Then we have control plane protection policies. So there are 2 chapters that are dedicated for security. So you will have dedicated classes, or you will be provided the video course for these 2 chapters for the NCORE people. Like anyone who is attempting NCORE, they will have to cover it. So either you will have dedicated like classes, or you will get the recorded like videos for these 2 chapters. Because you don't need to go through any lab or so, you just need to know from the theory point of view what are these security related products. Right, so again, no need to worry about it, but chapter number 2, chapter number 3, chapter number 4, and chapter number 5 we will cover from our official content point of view. Now, if you want to study in more detail, then there is one more book, which is old CCNP book, the previous content, like the CCNP switch that this exam we used to have earlier. This is no longer a valid exam, but this CCNP switching book actually is also like very good for your CCNP CCIE level of concepts. So you can either download this book from the internet, or you can get it from the portal itself. Again, So first chapter here, designing the enterprise network. Then like here they have talked about like what is switch operation, MAC learning and all those things. So what is switch, how the switch actually learns the MAC address, what type of switches are there, basically everything that you should know about the switches they have discussed here. Then design the campus network, what is VLAN, what is trunk. Then VTP, no longer part of our content, so don't read this chapter number 5 from this book. Working with redundant link, that means STP, 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 like a spanning tree protocol. So of course you need to cover the spanning tree protocol in very detail. They have given these things. Then we have like these ether channel protocols, PAGP, LACP, ether channel link bundling concept. So this is what you will cover. In the multi-layer switching, we have DHCP, we have Ceph. So you want to read about inter-VLAN routing, you want to read about Ceph, Cisco Express forwarding, those techniques, you can read it from this multi-layer switching chapter. Then we also have DHCP. Then monitoring, SNMP, SLA, logs, span, RSpan, these are those things. This is a very good book, like HA, high availability. High availability focuses on that content such as like these VSS stacking, right? Then FHRP, VRR, which has like HSRP, VRRP, and GLBP. So this is like HA, high availability. Then security, like securing the VLAN, basically like security related features such as DHCP, snooping, dynamic IP inspection, and all those things. It is covered in this one. So this entire book actually, and then this entire book is suitable for our enterprise infrastructure lab content. So if anyone is preparing for the enterprise infrastructure lab, must go through this book as well. Anyone who is preparing for the ENCORE exam must find the topics that are common and must go through this book as well. This is a very good book that discusses basically things in very much detail.
This is old book, so they are not virtualized and they are not mentioned.
Virtualization and those things, like they are not mentioned. But when we talk about virtualization, they still in this one they have not mentioned anything actually. But in like the, and one more thing, we don't have any official book for CCIE Enterprise Lab. There's no official book for CCIE Enterprise Lab. We have ENCORE book. Based on the ENCORE topics, you go in the like CCIE, right? So there is no official book for the CCIE. Actually, there is one book for CCIE Enterprise Infrastructure Lab, but that is just lab. There is no theory in it. Narvik one. Narvik has actually, Narvik Kocharian, Narvik has actually written one book that officially is being used by Cisco for like CCIE Enterprise Infrastructure, but that book is pure lab. There is no theory in that book, right? So you have to cover the theory from books like these, books like the ENCORE, you have to cover it. And still, if you want to know more about it, then you of course have this, like, you know, old CCIE version 5 book we also have. So old CCIE version 5, like if you search CCIE routing and switching version 5, just search CCIE Enterprise, CCIE routing and switching, the old version before this enterprise came into the market. So CCIE routing and switching, like version 5 official cert guide, like you can search this and you can download this book either from like any website, or again you will get it from the portal. So there is not one single book, we have multiple books that you need to go through, and going through those books you will cover your official switching content. Now about the lab, how we are going to cover the lab. So the lab that we are going to cover is going to be based on our EVNG platform. You can use either, since like most of the candidates are online, right? So like you can use EVNG or you can use GNS3. GNS3, if you want to use, you have to have it like based on the VM, I think version 2 or something, it supports it. But I would recommend you that, you know, you go for like EVNG. It's a good platform for like multi-vendor environment. So EVNG, like we are going to build a basic lab in the EVNG, and if you want, I can provide you that UNL file so that like you can directly just run that file on the EVNG, right? So I will be doing the labs on EVNG, and if any topic that is like that cannot be covered in the virtualized solution, then I'm going to use the real device for it. Right, so I do have like a few devices in my like here office. So here I can take the access of a few switches. So any topic, there are a few topics that you might see not working properly in your EVNG platform, such as, for example, storm control, test ether channel command. There are a few commands that don't work in your EVNG properly. So for those things, we are going to switch to the real devices. Only a few things. Like I would say 1 or 2% of the thing, they might 1 or 2 commands or 1 or 2 things they might not work properly in your EVNG platform. So for those, like we are going to cover it on the real devices. Right. So we will use this EVNG platform to cover like I would say most of our lab. If needed, then I will access the real devices. So I will request you guys to actually have this EVNG setup on your machine. You should have like at least 8 gig of RAM, at least 8 gig of RAM for this EVNG to work properly. If you cannot set up the EVNG on your machine, or you don't have enough resources, then you can drop the message to Mr. Saurabh, Mr. Sugandh, or whoever is in your contact, your account handler. From here, they will provide you the access on the lab access on the cloud as well. Just like you have the access for the SD-WAN, just like you have the access for the other technologies, firewall and all. So they will provide you the access on the cloud as well. However, you will not be able to do any packet captures or anything in there.
No.
This is cloud, so you will not be able to do any packet captures also, but rest everything will work fine. Right, so you will still be able to like you will get a pre-built topology. You cannot add or remove any new device. Whatever things we are going to practice, you can practice on there. So if you cannot set up the lab like on the EVNG platform on your machine, maybe because you don't have enough resources, you can actually have a discussion with Mr. Saurabh Sugandh or whoever is your account handler from here, and they will provide you the access onto the cloud as well. So I'm not sure if I still have the access to that lab as not, because I mostly like do the things on the EVNG platform on my machine. So I might not have the access to that, but you will get the access on the cloud actually. Yeah, I still have it. So this is the website dc.mylabs.cloud. From here, you will get the access to this switching class, right? So if this you will get the access of, right? So if you click on this, this is the lab that we will be working on anyway, and the same lab you will get in the portal as well. So this is the lab that we'll be working on. This is the similar kind of lab that we will deploy, that we will configure on our local machine, and the same lab you can either deploy on your machine, or you can get it from the these management from here. You can get like this lab from there. So you can like power it on, like more action, or you can just power it on. And once you power it on, when the switch is started, you can just take the access of this switch exactly like the other switches. However, you will not be able to do any packet captures. Done. So configure terminal, show IP interface brief, everything is like exactly the same. You will just not be able to do like any packet captures or so, but rest like you can still perform everything, all the things that you should know from the switching point of view, you can do it right here. So either you build your own lab based on EVNG, or get the lab from here by asking your account handler, right? So, and I will do the lab on my own machine based on the EVNG platform. If I require any real device access, then I will take the access of a real device, and then I will do the lab. Topology will remain same. Like we are going to have same topology. So in the same topology, we are going to have all the concepts of layer 2, layer 3. If I require a different kind of topology, then I will build it in my EVNG, and then I will provide you the UNL file so that you can do it at your own as well. But mostly all the things we will cover in this topology itself. Lab, once we start the lab, when I build the lab in front of you on the EVNG platform, then I will export it, and then I will upload it the previous classes. So when we begin with our lab content, when I build the lab, like the topology, then I will upload that topology. Right. So this is how we are going to cover the entire content. The content that we will cover will focus on the topics that we have discussed, and of course we are going to cover it with the help of some PPTs. The content that we will talk about, we will cover it with the help of some PPTs, and those PPTs you will get in a hard copy format, right? So we are going to use these PPTs. We are going to use like these PPTs right here. You are going to get these PPTs in the hard copy format. If it is not possible to send you these PPTs in the hard copy format, Mr. Saurav or Mr. Sugandh, they will be able to upload it onto the portal. From there, you can view it. You can see it on the regular basis about the topic. So we will start with the switching, and this entire content we are going to cover. It's not like a lot. This is the updated PPTs and all. So not a lot of things are there, but we will talk about like from this PPT itself. We will talk about like everything that we should know from the switching part. So and you will get these PPTs either in the hard copy format or you will get it onto the portal. You will not be able to download it. Just view it and then refer it for your like quick refresh. So you will not be able to download these PPTs. Just like on the regular basis, you can once you are revising and watching the videos and all, then you can refer to these PPTs for quick revision. Right. So so far, if you guys have any questions in the content, how we are going to deliver it, lab and anything, of course, like once our switching part is done, then we will also talk about what type of questions are expected for you to know from the lab exam point of view. Right. So we will talk about that at the end as well. Right then. So let's begin with our switching content. Let's talk about like what is switching. And throughout this content, we will talk about the use case of switching in our campus. We will be focusing on switching in a campus area network. We'll be talking about like all the switching related concepts, considering that we are doing switching in a campus area network. In an enterprise network, we are performing the switching. We are not going to talk about like switching and related concepts from the data center, for example, point of view, because there things might go a little bit different. So we will talk about like how in an enterprise campus area network, how can we perform switching? What are the things that we have from the switching point of view? Right. So first of all, what exactly is the switching? So switching is forwarding the packets based on this is the content that we just discussed, right? So switching is part of here. So we have talked about it. So what exactly is switching? So switching is forwarding the frames based on the layer 2 address. Forwarding of the frames based on the layer 2 address is known as switching. Now what exactly is a frame? Frame is basically a data that has been encapsulated at the data link layer with some Ethernet header and Ethernet trailer. So nowadays, the most common technology that we use to connect our devices, our routers, our switches, our like laptops, desktops, the most common technique that we use nowadays, and the most common technology that we use nowadays to connect all these devices together is called Ethernet. So we have in the market this thing called Ethernet switch. These Ethernet switches allow us, they allow us to connect our like various devices such as routers, such as like desktop, laptop servers, access point, WLC, all these networking devices with the help of Ethernet cable. Ethernet cable, like it could be fiber optical, it could be like twisted pair, it could be like coax. So Ethernet technology is used to connect like all these devices such as routers, switches, firewalls, like access point, WLC, your wireless, this laptop, desktop, all these devices together. So when we use Ethernet technology, when we are using Ethernet technology to send and receive the data via this Ethernet wire, via this Ethernet cable, the data that is generated by the device will have some extra information added on it. That extra information is known as header and trailer. So every data, when it is being generated by the device, will have some header and trailer attached to it. The data, let's say for example, is generated at the application layer. Let's say for example, we are talking about HTTP data. So HTTP, since it is an application layer protocol, the device will generate the HTTP data, give it to the application layer. Application layer is going to perform encapsulation over the data, which basically means that the application layer is going to perform some extra addition of headers onto that data. Like application layer is going to add some extra information on the data, then the data will be passed to the next layer. Next layer is going to be the transport layer. Transport layer is going to add its own extra information known as header. Since we know that the HTTP protocol uses TCP, the TCP header will be added. Then the data will be passed to the network layer. Network layer is going to add its own header information, which is like IP header. In the TCP header, what things are going to be added? The main things that you should know about, it is like source port number, destination port number. In the network layer, when the data arrives, the main information that is added is the source IP and the destination IP. Then the data, once it has been encapsulated at the network layer, then the data will arrive at the data link layer, and the data link layer, it will add the Ethernet header and the Ethernet trailer. In the Ethernet header, it will add the, like, this is like data link layer header and data link layer trailer, and here it will add the Ethernet header. In the Ethernet header, the main information that is going to be added is the source MAC address and the destination MAC address. So if a device is capable of forwarding this data, this is what, then the data is going to be sent to the physical layer in the format of bits. The data will move from the Ethernet wire towards the next device. So now, if we have a device such as, for example, switch, if we have a device such as, for example, a router, a device that can perform the packet forwarding, this in general I can say as a packet. In general, like packet, not the network layer packet, the packet, just the packet. So if a packet can be forwarded, if the device decides to forward the packets based on MAC address, if the device decides to forward the packets based on the MAC address, then that device is known as the layer 2 device, and this process of forwarding the data, this process of forwarding that packet based on MAC address is known as switching. So switching is a process of forwarding the data based on destination MAC address. Routing is a process of forwarding the data based on destination IP address. Any devices that forward the data, that forward the frame, because at the data link layer we call the data as frame. So any device that can forward the frames based on the layer 2 address is known as the layer 2 device, such as a layer 2 switch. Any device that can forward the data based on destination IP address is known as layer 3 device, such as a router. And if a device can include TCP UDP port numbers in its forwarding decision, then that device is known as the layer 4 device. If a device can make some decisions based on upper layer protocol such as HTTP, HTTPS, then that device can be called as a layer 7, and it means like the application layer device. So there are devices that work at layer 2 of the OSI model. There are devices that work at the layer 3 of the OSI model. There are devices that work at the layer 4 of the OSI model. There are the devices that can make their forwarding decisions beyond layer 4 as well, based on the application traffic. Now, Ethernet switching is not the only thing that we had. Like instead of, like, apart from having this Ethernet switching, we also had some other type of switching in earlier days. We had technologies such as, for example, ATM. We had technologies such as, for example, X.25. Basically, what I'm trying to say that we had different type of technologies, not only the Ethernet technology. So if you want to connect two or more devices together, if let's say, for example, we have this device, we have this device, and we have this device, and we have this device, we want to connect these devices together. Nowadays, we have the option to use this Ethernet switch. Based on the Ethernet switch, I can connect these devices with the help of the Ethernet cable. It could be twisted pair, it could be coax, it could be fiber optical. And then we can forward the traffic from one device to other device. The intermediate device, which is a switch, is going to perform the packet forwarding based on the MAC address. But this is not the only technology that we had. We had other technologies as well, such as, for example, in earlier days we had technologies such as ATM, asynchronous transfer mode. We had like X.25. We also had frame relay. We had like different technologies, such as, for example, we had like ATM switches. We had like X.25 switch. We had like frame relay switch. Just like we have these Ethernet switches nowadays, earlier we used to have like these switches as well. For example, a frame relay switch, it would have a frame relay switch. It will have like serial interfaces, and we can connect multiple routers with the help of the serial technology with the help of this frame relay switch. Frame relay switch, like they used to have the serial interfaces, so we can connect multiple routers together in a point to multi-point way. But nowadays, since Ethernet standards have evolved so much that Ethernet can not only be used as a LAN, but can also be now used as a WAN technology. Ethernet can also be used as a WAN technology, such as like, you can see fiber optical cables going on from one location to the location, providing you the connectivity from the service provider to the enterprise service provider to your home network. So since nowadays Ethernet standards have evolved so much that Ethernet can not only be used as the LAN, but as a WAN technology, these additional concepts, these additional type of switches, these additional type of switching mechanism, you might not see very commonly in your production environment. So the only thing that we need to focus as a part of our content in general as well, the only thing that we need to focus is the Ethernet switch and Ethernet switching concept. Now, when we specifically talk about like Ethernet switch, there is one thing that you should know, that Ethernet switch decides to forward the data based on the MAC address. Why we require MAC address when we already have the IP address? First of all, if this device already has an IP address, then why do we require why do we even require the MAC address? Remember that when we talk about like technologies such as like serial, if we connect two or more router with the help of a serial cable, this serial technology is actually a point-to-point technology. What do we mean by it? It means that you cannot even connect like three devices with the help of the serial. There is no serial switch nowadays. Like there is no switch that allows you to make this kind of topology, this kind of topology. There is no such switch. Serial technology is actually designed to work as a point-to-point technology. That means if I send some traffic from here, the traffic will exit from this interface and it will be received on this interface. There is no other way, there is no other path where the traffic can actually go. Since the serial technology is like a point-to-point technology, means any traffic that goes out of the serial interface will always be delivered onto the next device. We actually, since it is a point-to-point technology, we actually do not require, we don't need to uniquely identify the sender and receiver. All I need is a valid IP address 10.1.1.1, 10.1.1.2, and that's pretty much 10.1.2, whatever it is, and that's pretty much it. Since the serial technology is a point-to-point technology, we actually do not need to uniquely identify the sender and receiver. Why? Because it's obvious that if the traffic is placed on this interface, it will get delivered on the other side because there is no other path. So in the serial technology, in the serial interfaces, we actually do not have any concept of MAC address. We don't have MAC address on the serial interfaces. If you connect two or more router, with the help of like serial interface, you will not have any MAC address on there, because it's obvious that the data is going from router 1 to router 2 only, right? So we don't require any MAC address on the serial technology. You can see it. You can choose, like this is a packet tracer. So you can choose like any router on here, such as this router. So this is a packet tracer software. So I have used like two routers from this packet tracer software, and on this router on this router, I'm going to click on this router, I'm going to power off this router, and I'm going to add one serial interface on there. I'm going to power it on. I'm going to power off this router. I'm going to power off this router. I'm going to add VIC1T. VIC1T means VIC WAN interface card. 1T basically means one serial interface. So VIC1T means one WAN interface. Serial technology was very popular for the WAN connections. So VIC stands for WAN interface card, and 1T means one interface, one serial interface. 2T means two serial interfaces. 4T means 4. 8T means 8. So basically, like VIC stands for WAN interface card, which we can use to connect our router to router with the help of the serial cable. So I have done, I added one WAN interface card on this router, and I added one WAN interface card on this router. And now I'm going to go to the cable option, and I'm going to connect this with the help of the cable, serial to serial. This is a type of connections that we can have between the routers. We cannot have this connection between the switches, because switches, they don't have serial interfaces. We cannot connect like multiple routers together with the help of a switch, because Ethernet switches we don't have, like in modern day network, we don't have frame relay switches, ATM switches, X.25. We don't have those technologies anymore. So you are not going to see like multiple routers interconnected together with the help of a serial cable. Ethernet is being used now as a WAN technology. So if I go on this router, if I click on this router, if I go to the CLI and I just use the command, show interface serial 0 by 0. If I use this command, I can see here one by 0. Show interface serial 0 by 1 by 0. If you take a look at this information in very detail, you will find that here we actually do not have the MAC address. You can take a look at this output completely, and you will not find MAC address onto this interface. We don't have MAC address on this interface. We don't have MAC address on the serial interface. Why? Because the protocol that is responsible to send the data, to encapsulate the data in case of serial technology, does not require the sender and receiver to be uniquely identified. Why? Because it's obvious. If there is only one path, if anyone sends some traffic, it will definitely be received on the other path only. From this end to this end, point-to-point connection does not need the sender and receiver to be uniquely identified. So on the serial technology, we have protocols such as HDLC. We have protocols such as point-to-point, PPP. These protocols, they do not require any MAC address, because it's obvious that the traffic will go from sender to receiver only. But if the same thing we do, if we have, let's say, for example, again, if we have like multiple routers, and we connect these routers with the help of an Ethernet switch, with the help of like Ethernet cable, right here. If I connect it with the help of Ethernet switch, with the help of Ethernet cable, now it's not obvious. Now, if you want to send the traffic, from, let's say, from here to, let's say, from here, 10.1.1.1 to 10.1.2.1. Let's say you want to send the traffic from this LAN subnet to this LAN subnet. When the traffic arrives onto this router, now it's not obvious. It's not obvious where this destination actually is. This destination could be on here, this destination could be on here, could be on here. So since we have connected these multiple routers with the help of Ethernet technology, the Ethernet header will be added onto the data at the data link layer, and that Ethernet header will have the source MAC address and the destination MAC address. Why? Because Ethernet technology is a multi-access technology. Multi-access basically means we can connect multiple devices together with the help of the Ethernet technology. And now it's not obvious. It's not, assuming that you know about static routing. Okay. So if I go on this router and I configure a static route to reach out to this destination. right? And I just mention the exit interface. I don't mention any next hop. I just say IP route 10.1.2.1 to 55.255.255.255 and the exit interface. How this device will find out if the traffic has to go here, here, or here. ARP, and but ARP, again, we have not given any next hop MAC address, so how the ARP will work even in that case. Anyway, the point is that since Ethernet technology is a multi-access technology, it might not be obvious that the traffic that exits this interface will go here or here or here. We need a unique source source MAC address and the destination MAC address so that the sender and receivers can be identified uniquely. So we require MAC address on the Ethernet technology just because the Ethernet technology is a multi-access technology, and in the multi-access technology, it's not obvious who is the sender, who is the receiver. So we need to uniquely specify the sender and receiver. And to uniquely identify the sender and receiver in a multi-access technology, we require MAC addresses. Serial technology does not require it, because in serial technology, we always have P2P connections. And in the P2P, it's obvious that the traffic will go from here to here. That's why serial interfaces, they don't have the MAC address. But if I check the same command here, if I go here and if I check the same command here, you will find show interface FA 0/0. You will find that this interface actually has a MAC address. Hardware address. This interface actually has a MAC address. Why this interface has a MAC address? Because this is an Ethernet interface, and Ethernet interface is a multi-access technology which requires the sender and receiver to be uniquely identified. So now, when this device generates the packet, sends it towards the next device, it will add its own MAC address as the source MAC address. It will add the destination MAC address, the next hop MAC address as the destination MAC address, and forward the packet towards the switch. Switch will now take a look at that MAC address, and based on that destination MAC address, it will decide if the traffic has to go here or here or here. So any device forwarding of the frames based on the layer 2 address, which means the MAC address, is known as switching, and any device that can forward the frames based on the layer 2 address is known as layer 2 device, such as a layer 2 switch. We require the MAC addresses in the switching. We require the MAC address in the Ethernet based switching. We don't require the MAC address in the frame relay switching. We don't require the MAC address in other switching technologies. Since those technologies either are not being used or have gone obsolete, we don't need to worry about those technologies. So we have layer 2 switch, layer 3 switch, and the multi-layer switch. In most of the cases, multi-layer switch and the layer 3 switch, people assume they both are the same thing. Layer 2 switch can forward the packet based on the layer 2 address only. Layer 3 switch can forward the packet based on the layer 2 and layer 3 both. Basically, this layer 3 switch can perform switching and what? Routing. Both it can do. There are switches in the market that can perform both routing and switching. They are equipped with both the hardware. They are equipped with both the components. Within these switching hardware, we have a switch and we have the router as well. Within the switch, we have both switching hardware and the routing hardware. So this switch can perform both routing and switching. These kind of switches are known as the layer 3 switches. If a device only has the switching capabilities, if the device can only forward the packet based on layer 2 address, then it is known as a layer 2 switch. If the device can do the packet forwarding based on layer 2 address and layer 3 both, means like MAC and IP both, then that switch is known as the layer 3 switch. Now, since layer 3 switch can perform both routing and switching, people call it multi-layer switch. However, the real multi-layer switch, the definition of the real multi-layer switch is a little bit different. A multi-layer switch can take the forwarding decision based on layer 2, layer 3, that's okay, and based on the port numbers. Multi-layer switches actually can perform packet forwarding based on MAC address, IP address, and the port number. Multi-layer switches can include port numbers in their packet forwarding decision, which gives us the difference between a layer 3 switch and the multi-layer switch. In the multi-layer switch, we can perform netting. NAT is dependent on the port number. So netting we can do on the multi-layer switch, but we cannot perform netting on the layer 3 switch or the layer 2 switch. There could be other differences as well, but the major difference between a layer 3 and a multi-layer switch is that a multi-layer switch can include layer 4 addresses, such as, for example, port numbers in its forwarding decision. So layer 2 switch can only perform switching, layer 3 switch can perform routing and switching both, and layer 4 or multi-layer switch basically can perform routing, switching, and can also perform things such as netting. Basically, including the port number in its forwarding decision can be done by this multi-layer switch. However, this line between the layer 2, layer 3 and multi-layer switch is basically growing, like it is going like thin day by day. Like you will, like all the switches that Cisco offers nowadays, you will hardly be able to tell the difference between the layer 2 and layer 3 switch. Earlier we used to have layer 2 switch, Catalyst 2950 series, for example, which is a very popular switch that comes under layer 2 category. Earlier we used to have layer 3 switch such as 3750, 3760, 3850, 3860. These are the switches that were categorized as the layer 3 switch. In the multi-layer switch, we used to have 45, 40, at least 4K, 4500, 46, 47, 6000, 9000. But basically, we had like different platforms for like multi-layer switches as well. 45, 65 being the most popular platform. Yes. At least 4K and 6K series switches were very popular multi-layer switches. But this layer 2, layer 3 multi-layer switch concept actually, like in a today's campus area network, in a modern day campus area network, it's not even about like layer 2, layer 3 or multi-layer. It's all about 9K series switches. In the modern day Catalyst, in the modern day campus area network, you will always, mostly, if you are going to purchase a new switch, you will always order a Catalyst 9K series switch. So Catalyst 9000 series switches are, you can say, the switches that Cisco has created for our modern day campus area network. These Catalyst 9K series switches actually have some specialties. They have some special hardware that allows these switches to be managed via a centralized controller as well. So we can do the management of all these switches one by one, and we can also do the management of these switches with the help of a centralized controller, which is a part of software-defined networking. So modern day campus area network is built not around Catalyst 2950, 3750, 3850. It is built all around like the Catalyst 9K series switches. Catalyst 3K and 6K series can also be seen in some campus network. If you still have a Catalyst 3850, 3860, you are not going to throw it away. You can still use it. But if you are going to order a new switch platform for your campus area network, you will always order Catalyst 9000. And like, you know, you can relate actually. You can relate, like for example, all the Catalyst 2000, 2950, 2960 that we had, it is now relabeled as Catalyst 90-100 series switch. You will find similar functions that we had in the 2950, 2960 in the 90-100 series switch. Earlier we had Catalyst 3750, 3850 and all that. They more have like, you know, updated the hardware and everything, and they have launched these Catalyst, very popular switches. Catalyst 90-100 series switches are very popular switches in the Cisco platform, in the Cisco portfolio that are used in the campus network. Then we have 94, 95, 96, 97. We have similar, like we can relate actually. Like earlier, whatever was 2950, 2960, those functions can nowadays be seen in a Catalyst 90-100 series switches with some additional advantages. Advantage being the capability of the switches to be managed from a centralized controller. Catalyst 3750, 35, 37, those Catalyst like layer 3 switches that we used to have earlier, now these are like 93, 45, 46, 94, 65, 96. We have like different platforms, but it's all about Catalyst 9K series switches.
They want to keep the whole density.
They have added like more, exactly. They have like upgraded the hardware,
Yes.
but the basic functions of like switching still remains like on in these new switches exactly the same as they were in old Catalyst 2K 3K series switches. But there's one thing that you should know. Again, all of these switches are capable of performing routing.
Yeah.
Here. Catalyst 9K series switch data sheet. If you want to know about like any switch in detail, just search this data sheet. Just search Catalyst. Okay. Catalyst 9K series switch data sheet. Right. Just search it. Click on the first link. It will give you like the option like Catalyst 9300 series switch data sheet. You can go for like other series switch platforms as well, and you will find that if you go through these data sheet, they will tell you all these like options that are there. All these. This is how a Catalyst 9300 series switch looks like. This is how a Catalyst 9300 series switch looks like. This is how a Catalyst 9300 series switch looks like. So if you can go to like this a platform detail, you can see the benefits, you can see the software requirement, you can see all those things, and here from here you can actually see the capabilities. Like here, features, you can see here it says that we have, where is that? You can see here that we have all the switching functions and we also have routing functions. So this Catalyst 9300 series switch can perform both routing and switching. Okay, fine. So we can categorize this switch as our layer 3 switch. If you go through like a data sheet of Catalyst 9200 series switch, if you go to the data sheet of Catalyst 9200 series switch, this Catalyst 9200 series switch, which relates to the 2000 2950 2960 series switches that we had earlier, you go through it, you check it here. So it also has some routing capabilities. So we are not going to categorize this switch as the layer 2 switch. This is also more like a routed, this switch is like a routing enabled switch. Similar to that, we have like, you can always take a look at the data sheet. You can always take a look at like these data sheet of Catalyst like 9400 series switch, 9500 series switch. You can always take a look at the data sheet to find out the features that are available onto that particular platform. Here, these are the features that are available onto that platform. So the point is that this concept of layer 2 switch, layer 3 switch, multi-layer switch, this concept is like actually getting weaker and weaker day by day, because most of the switch platforms, they nowadays come with the routing capabilities enabled. Like 92 comes with routing, 93 comes with the routing, 94 comes with the routing. So we are hardly going to have like any layer 2 until you have like any old 2950 series. In fact, 2960 also has the routing. OSPF runs on there. 2960 also has some basic routing features. So 2950 series switch, if we have like still in your production environment, then you can call it a layer 2 switch. Otherwise, most of all the switches in a modern day campus, most of all the Catalyst 9000 series switches, they all are layer 3 switches. They are equipped with the routing and switching both the functions. And the major advantage of these switches is that we can not only manage these switches one by one locally, but we can also manage these switches with the help of a centralized controller called DNA center. We have Cisco has created a controller called DNA center, and that DNA center actually can manage these switches from one centralized point. It can be used to create like our network. Basically, DNA center can discover those switches, DNA center can configure those switches, DNA center can do a lot of things onto those switches. It can build your whole topology onto the switches and all. Basically, we get software defined capabilities in a campus area network based on these Catalyst 9000 series switches. So like I said, most of these switches are nowadays routing capable. So the line between the layer 2 and layer 3 switch is basically like very thin nowadays. You will hardly see a switch that is only having switching capabilities. Most of the switches, they will have routing capabilities as well. And why? Because of this SDA. Because they are telling you to build routing network, routed network, rather than building a switched network. They are telling you that when you design your campus local area network, don't design it based on layer 2, design it based on layer 3, so that later on, if you decide to use DNS center as a controller, it will be easy for the DNS center to manage all the switches from one centralized point. So they are telling you to build your network, campus network based on layer 3, not based on the layer 2. And that's why they have removed a lot of layer 2 topics, such as VTP is no longer there, such as DTP is no longer there. Why DTP is not there? Because we will not require trunk between the switches. Why? Because it is going to be a layer 3 link. It is the link between the layer, this access layer switch and this distribution layer switch is no longer going to be a layer 2 link. They are recommending, they are telling you to use a layer 3 link between the same. And if layer 3 link is there, that means there will be an IP here, there will be an IP here. You will not require trunk. And if you don't require trunk, you don't require DTP. You will not require to send the VLAN information from one switch to other switches. Why? Because the VLANs will be pushed by the DNS center automatically. So we don't require VTP. Why? Because software defined networking. We do not require GLBP. Why? Because our access layer switch, the switch from where our end user is connected, this itself will become what? The default gateway. We don't even need any HSRP, VRRP or GLBP kind of protocol. So since they are moving from the traditional network to the software defined network, they have decided to eliminate a few topics from our switching content that are more like, that are irrelevant, or they will go irrelevant in the near future. Right, so all of these switches that we have, all these Catalyst 9K series switches, they have the capability to be managed from one centralized controller. Okay, these are like Catalyst 9K series switches. We still have 3K, 4K, 6K series. I'm not saying that it has gone obsolete. I'm saying that if anyone decides to build a campus local area network, they are going to order a Catalyst 9K series switch. So these are like switches that are used in a campus area network. We have Catalyst 9K series switches, 3K, 4K, 6K. Actually, these switches also have the SDA capabilities. So we can still use the software defined access, software defined networking capabilities. I would say these switches also have the SDN capabilities. That's why like these are still relevant. These are still available in our production environment. Otherwise, anyone who has to migrate from traditional to the software defined, they have to get rid of these switches. But anyway, since these switches can be used for software defined networking, these are still like being used in your production environment. Same goes for other platforms such as 45, 65 and 68 series platforms.
In 2025.
Maybe like, yeah. They have already announced like end of sale, end of life, end of support. They have already announced the end of sale and all those things for like these switches. In the near future, you will always see Catalyst 9K. And not only Catalyst, everything is now Catalyst. Not switching, everything is Catalyst. In Cisco portfolio, everything is Catalyst. Catalyst SD-WAN. DNS Center has now been renamed to the Catalyst Center. Switching is already switching, Catalyst switches. So they are basically like, Catalyst is more like a term that they are using for everything nowadays.
In fact, in ACI also they have using that 9K same devices there, just only the software
function. Exactly. So anyway, like it is going to be like 9K series platforms in all the environment, you can say. And we also have some switches that comes with embedded wireless LAN controller facility. Means like if you have multiple access points in your network and you want to manage those access points from a centralized point, we need to purchase a wireless LAN controller. That wireless LAN controller function, this software can run on these Catalyst 9800 series switches. In fact, 9800 series switch also comes with the Catalyst WLC functionalities. We have some 9800 series switches in our premises, and that have the embedded wireless LAN controller function. Basically, wireless LAN controller functions can also be enabled on the box. We don't need to purchase a dedicated wireless LAN controller to manage all the access points of our network. Those functions can also, maybe someday we will do the upgrade and I will show you how that works, but that capability is actually there. These are most commonly utilized Catalyst switch platforms that we have. And remember, Catalyst world is not only for switching nowadays. Catalyst world is for like almost everything. They are using like Catalyst world like for they announced this like 3-4 months back actually, when they had like Cisco live event. They actually announced that we are rebranding everything and everything will now be Catalyst. So Catalyst stack, we call that, not stacking, stack. Catalyst solution is stack. Catalyst SD-WAN, Catalyst like DNS Enter, Catalyst switches, like everything. They are basically like, you know, I would say moving to the Catalyst and like that. Okay. I was going to show you a link post actually, but like they renamed it on like in Cisco Live June 2023. On June 2023, they actually renamed their SD-WAN solution, their DNS Center solution, the wireless solution, all to Catalyst, like Catalyst. Anyway, so these are the switches that we will see in our campus area network. We will build our enterprise network based on these Catalyst switches. And what type of switches? All switch products. You search all switch products Cisco, search something like that and click on this link, and it will give you every, for example, switch platforms that they offer. So for example, like we have some blade switches, industrial Ethernet switches, campus local area network, access layer switches, campus local area network, campus LAN, compact, core distribution, data center, small businesses. They have like different categories. So if you have a small business, you can go for like these switches. Where Catalyst Cisco Business 350 manage the switch. This is like a small series switch that they have manufactured for small businesses. Since we are talking about campus local area network, these are the switches that we can go for. So if you see 94, 93, 92, you have 96, 95. So basically it's all about Catalyst 9K series switch platforms. And you want to know in more detail about it, just click on this. Just click on this switch. It will open a page. From here you can see everything you can know about. Like we have these models, Catalyst 93X fiber high performance, like PoE, 60 watt PoE, 90 watt PoE, 1 gig model. They have like all these different models, and we can read the data sheet right from here. All the data sheet, all the, you know, everything that you should know from the Catalyst 9K series point of view. You have this data sheet, download this data sheet, keep it with you, right? So that when you are placing the order, you can get the information from here, and based on that you order a switch for your production environment. So they have given like a comprehensive like differences like in between all these different platform switches, how many ports are going to be there, what uplinks are going to be there, everything that you should know, it is there in this big data sheet. Since we are not going to order any switch, we don't need to worry about it, but you can definitely take a look at this document that they have given to know more about like in very detail about these like. And since we are talking about it, earlier we need to install some software. We always need to install some software on the hardware. So let's say even if we purchase a Catalyst 9200 series switch, we need to have some software in it. That software is known as iOS. We have iOS, Internet Operating System, Internet Working Operating System. We have iOS. iOS is the operating system for router switches. Like it is the operating system for router switches. And nowadays there is a flavor of this iOS. There is a version of this iOS that is known as iOS XE. iOS, there is iOS, there is iOS XE, and there is iOS XR. We have like three. There are three versions of, like, I would say, iOS. We have like normal iOS that runs on routers and switches, traditional routers and switches. Then we have iOS XE. Then we have iOS XR. So all these Catalyst 9K series switches, they have this thing called iOS XE. This is more like a flavor. This is like a version of the iOS that Cisco has installed on all these devices. This iOS XE has all the functions that you need to maybe like enable all the switching capabilities, routing capabilities, even manage these switches from one centralized point. So all the things that we require from the routing point of view, from the switching point of view, from the SD networking point of view, SDN point of view, everything is there in this software called iOS XE. So we have Catalyst 9K series switches with iOS XE installed on those switches. And iOS XE actually has, when you purchase a switch, you need to purchase a license for the switch as well. So earlier, based on our requirement, we used to have licenses such as IP service, advanced IP service, security service, advanced security, enterprise, advanced enterprise. Earlier days, we used to have different type of licensing. Now they have only two licenses. Now they have either, when it comes to licensing, basically means like what feature you are going to get. Based on the license, you are going to get certain amount of features. So we have a license called, there are two licenses, essential license, and one is called advantage license. That is it. I'm talking about like switching, network essential, network advantage. I'm not talking about software defined networking. I'm just talking about our traditional switching. So we have network essential and we have network advantage license. Network essential and network advantage license we have. What we are going to get from the network essential and network advantage license point of view here. Let me show you a document which you can also download. You will get on the portal. Here is what you get. See, the first column here is network credential and the second one is what? Network advantage. Okay, so see what you get. So you get these things. If you have like network credential license, you will get these things here. What you get? You get, yeah. So if you have a network credential license, what you get? You get layer 2, means you have all the switching functions. Then we have routed access, OSPF, policy based routing, PIM, multicast, okay, whatever it is. So you get all these options. If you have network essential license, then you get all these options. You have options for like, you have all the basic essential switching capabilities, you have routing capabilities, you have programmability. Basically, you can use some automation tools to manage our network as well. We have like netconf, restconf, GTP, MAC encryption, SPAN, RSPAN, streaming telemetry. These are the things that you get if you have the essential license. And if you have like the advantage license, then you will get all these things. In addition to that, you will also get, in addition to that, you also get these things. You get full routing capabilities. That means BGP and all. You don't get BGP here. Like here, you get only these things in here. You don't get BGP on here. So if you have like advantage license, then you get full routing capabilities. You get like things such as VRF, HA. You have some lifecycle management. We have some advanced multicast, MAC encryption, encrypting the packet on MAC capable devices. Basically, like these are the additional functions that you get in the network advantage license. So based on your requirement, either you are going to have the network essential or the network advantage license, and you have to specify this license right at the time of purchase. you cannot purchase a switch without a license nowadays. It is basically not possible. And you will also, since we want to later on use the software defined functionality, we want to use like our DNA center to manage all these switches from one centralized point. We need to purchase the licenses for like DNA as well, which we will someday discuss in our SDA classes. Right, so in you can see like DNA Essential license is there, DNA Advantage license is there, DNA Premier license is there. These licenses actually enable software defined networking in your campus network. So if you have these are additional licenses, these are called add-on license. Add-on license basically means you get like all the basic functions here, and in addition to that you get like some SD networking, software defined networking functions as well. You get all these options and you get some additional software defined functions based on these DNA licenses as well. So like if you have like DNA Essential, DNA Advantage, then you get like these features and all, which someday you will cover in the SDA classes. But this is what you need to know, that all the switches that we have in a modern day network, they will come either with the Essential license or the Advantage license. If you have the Essential license, you will get these functions. If you have Advantage license, then you will get these functions. And you have to specify this right when you are actually placing the order. So Cisco, Commerce Workspace. So if you want to order a Cisco switch, you can go to the CCW, Cisco Commerce Workspace. You can log in with your Cisco account, and from here you can place an order for the switch. And while placing the order, you need to specify your license, what license you actually require. So maybe we will see actually from here, but you can go to the catalog, you can go to the switches, right? And from here you can see these different types of switches that Cisco sells. You can let's say for example you want to purchase a Catalyst 9200 series switch. Click on this switch. Here is that switch. So like how much quantity you want to purchase and all, you enter. And if you want to add on the licenses and some additional thing, click on the configure button, and from here you can actually add on the additional things such as additional licenses and all. So point remains the same. If you want to purchase the switch, you need to purchase, see here, right here, DNA Advantage, DNA Advantage, Network Advantage, NWA, Network. This switch is with Network Advantage license. Purchase it or leave it. You don't have the option actually to purchase just the switch. You have to purchase the switch with the license. So Network Advantage, and add on to that DNA Advantage. Network Essential, addition to that DNA Essential. So once you are done, then you can just add this switch into the portfolio, and then just accordingly you can. So these are very these are not very, I would say, cost effective switches. These are these are very costly switches, but if you purchase like in bulk, you get the discount. You purchase it from Cisco partner, then you will get the discount. But eventually you are going to purchase these three switches and you are going to build your campus area network. So you can still have like old switches, but if you are going for the new switches, you will purchase like these switches, 9 to 9 Catalyst 9K series switches, and you are going to build your campus area network based on the same. Now these switches have different types of port. Some switches have like layer 2 port, some switches have layer 3 port, which we will talk about in tomorrow's class. I'm going to use like basic, I'm just going to use one simple switch here. I will use the EVNG, and I'm just going to use like simple switch. I'm not going to create like any big topology for the moment, just a simple topology with the switch. So I'm going to use EVNG as discussed in the last class. Right, so in the EVNG platform, I'm going to use this switch image that we have, and that image we are going to use for the switching purpose. So I'm going to choose the, so there are two types of switches here, like in this EVNG platform. Either you can have like switches that run on RAM, or the switches that can run on the CPU. Like there are two types of switches that we have. There are two types of node actually that we have in the EVNG platform. You can refer to the official documentation of EVNG to know more about it. But basically, there are two types of images that we have in the EVNG platform. One image consumes RAM and one image consumes CPU. So if on your machine you have limited amount of CPU, you can always go to the task manager, and on the task manager you can confirm like how much resources you have. So if you are running like, let's say for example, you do not have like sufficient amount of CPU, such as for example here I have like total 16 CPU in my laptop, right? So on my laptop I have total 16 CPUs in total, and when it comes to memory I have 16 gig of memory, so which is like sufficient for routing, sufficient for switching. I might be able to run like one or two firewalls, but not more than that. I cannot do SD-WAN lab, for example, basically in this much amount of resources. So if you have like sufficient amount of memory, you should always use the images in the EVNG platform that actually consume RAM. And if you have enough amount of CPU, then you should always use the image that consumes CPU in the EVNG platform. So the image that I'm going to use is going to consume RAM. So these images are known as IOL image. IOL means iOS on Linux. So what they did, actually they created these customized images, and these images are basically for the simulated environment. You cannot use these images exactly same as the real device. So this IOL basically IOL images are those images that consume actually RAM. They do not consume any CPU. So CPU utilization will not go very high. Your laptop, desktop will still be running properly. So from here you can choose like L2 image or L3 image. L3 image if you want to do routing, and L2 image if you want to do switching. Remember one thing very clearly, understand, there is no layer 3 switch image onto the EVNG platform. There is no image for layer 3 switch in the EVNG platform. It's like it says layer 2, which means that it is a layer 2 switch image that we are going to use in the EVNG platform. Layer 3 means router. So if you are thinking that this is a layer 3 switch image, no, it's a router image. It is not a layer 3 switch image, it is actually a router image. So layer 2 basically means like we are using like layer 2 means switching image, and we do not actually have the layer 3 switch image actually. In EVNG platform, we only have layer 2 switching image. However, like we can do routing in it. This layer 2 image that we have, it supports routing. We'll talk about it, but we do not have like any layer 3 switch image. The same image can be used for the routing, and same image can be used for the switching. That means that this image can be used as like layer 2 and layer 3, both the images, right? So anyway, when you log into your like EVNG platform, you are going to use this layer 2 switch image, which is going to give you both the options to perform like switching as well as the routing. Change like the host name to switch number 1, SW, add like you can add multiple nodes and all that. Since it is not an EVNG class, so we're not going to discuss more about it, but you can always take the images, you can always take more than one number of images and all, and change the image and something like that. So I'm going to use like, I only require only one switch actually. I only require like one switch. I don't need more than one switch for the moment, but I have just selected like a few more switches for later use. So this is one switch that I'm going to use in this EVNG platform, right? So this is one of the switch that I have taken. And for the host purpose, like for the end user point of view, I have two options. Either I go to the node and I can use this VPCS. VPCS means virtual PC, which basically means like it is just going to give you a Linux based like PC, which from where you can do the IP addressing, ping trace, and those things, basic things. It is not going to consume like a lot of resources. This is not going to consume a lot of resources. But what I'm going to do, what I always do, I do not use like these VPCS for our host. What I do, I actually use these routers as the host. So I'm going to do the same again. I'm going to click on node button in the EVNG platform. Then I'm going to go to the again IOL. I'm going to click on IOL. In the IOL, I'm going to choose L3. L3 basically means routing. So I'm going to name it like host because I'm going to use it as like host machine, and I'm going to change the symbol of it to computer so that it looks like we are using a PC. Just changing the icon and everything will not make it a PC. It will still remain the router. So there are a few things that we can do from the router better way than the PC, that VPCS. So I'm going to use this like desktop here, and I'm going to add like a few nodes. I will add like maybe 8 nodes here for the PC, right? So these are like, I'm going to connect a few nodes on here. So this is a layer 2 switch image. This is a layer 3 router image, which I'm going to use as a PC. And then I'm going to connect it with the help of like cables, something like that, 0 by 0, 0 by 0, 0 by 0, 0 by 0, 0 by 1, 0 by 1. It doesn't, you don't need to exactly match the interfaces, but anyway, so something like that we are going to connect these devices. Remember that if you are using, ENG has two versions, community version and a pro version. So in the community version that we are using, it is completely free, no costing and anything. But in this version, once you connect the devices and you power it on, you cannot delete, add new cables. If the device is running, you cannot add, delete new cables. You have to stop the devices and then you can disconnect the cable. You can add the cables and everything, but you cannot add or remove the cable if the device is already running. That feature is in a pro version. We don't need that anyway. So this is a basic thing, basic topology that we are going to use for our next discussion, that is on the ports, type of ports that we have on the switches. I'm going to select it. I'm going to start these devices. Already I said in the last class that you guys can download this ENG from the internet. You can upload the images. Otherwise, you can get the image. You can get like complete pre-built ENG from here, or you can go to the D cloud, and from there you can do all the labs. You have multiple options, whichever. If you have enough amount of RAM resources in your desktop laptop, then I would suggest you to deploy the ENG platform onto your machine, because anyway, today or tomorrow you will have to work on some virtualized solution. So it will be a good idea to deploy the ENG on your local machine. If you need any help, contact the administration, like contact Mr. Saurabh, Mr. Sugandh, or whoever like is in your contact with. You can drop them a message. They will share you the link to download the ENG, completely uploaded with images and everything that you require, and you can just directly run that ENG on the laptop. If you don't have enough resources, then you can always go for the dc.mylabs.cloud. You can get that cloud-based access as well. You can run all the commands. The cloud, right? Send that. No. In the cloud, you will have a fixed topology. You have to work on the fixed topology. Yeah, but the point is that all the things that we will do, we can do all the things on that cloud solution as well. We can do all the things, but the topology will remain fixed. In the last class, the topology that we saw, the big topology, that will remain fixed. For basic things, you can also use packet tracer. I have seen like in many places, like a lot of things still work on the packet tracer. Like if you want to just do some basic testing, packet tracer is sufficient. However, a lot of things don't work exactly the same way in the packet tracer. There are here and there some issues actually. So I would suggest you not to use packet tracer at this level. Packet tracer is just for the beginners, CCNA level. For CCNP, CCIE, I would never recommend anyone to use the packet tracer kind of software. So as much as possible, either use ENG or use real devices or use some cloud solution, completely up to you. But do not use like, until it's very required, do not use like software such as packet tracer. So what we need to discuss today, the first topic that we need to discuss today is like the type of ports that we have on the switch. So as we covered in the last class, that we have two types of switches. We have like layer 2 switch. Where is that? We have layer 2 switch, we have layer 3 switch, and we have this thing called multi-layer switch. Now layer 2 switch works on the layer 2 address, which is MAC address. So layer 2 switches can make the forwarding decision based on layer 2, means the MAC address. And the layer 3 switches can make the forwarding decision based on both layer 2 and layer 3, means IP and MAC both. And layer 4 or multi-layer switches can also include the port numbers in their forwarding decision, which gives them the ability to perform NAT, which is typically not available on a layer 2 switch or even on a layer 3 switch. So sometimes in interview, not for you guys, but for CCNA, CCNP candidate, sometimes they ask like in interview, if let's say if we are having a layer 3 switch in our network, why can't we replace all the routers with a layer 3 switch? Because on layer 3 switch we have a lot of ports, On the layer 3 switch, we can configure the IP address, we can perform the routing. So since all the routing functions are there in the layer 3 switch, so why don't we replace all the routers with the layer 3 switch? You actually cannot, because there are still a lot of functions that the router can do, but your layer 3 switch cannot do. NAT being one of them. So you cannot replace like all the routers with a layer 3 switch, because even though you will be able to perform routing and everything, but certain functions such as NAT will not work. However, you can replace a router with a multi-layer switch, because multi-layer switch can perform netting and ACLs and all those things. So you can replace that router with a multi-layer switch, but the cost of a multi-layer switch versus a simple router, you have to find that out. Now, if you have a layer 2 switch, things are simple. If you have a layer 2 switch, you don't need to worry about it. On the layer 2 switches, we only have layer 2 ports. What is a layer 2 port? Layer 2 port is a type of port that works on VLAN. Like layer 2 ports cannot be configured with any IP address. Layer 2 ports are those ports that are part of certain VLAN. What is a VLAN? One VLAN basically means one network. One VLAN basically means a broadcast domain. What is a VLAN? Which we will cover later on. VLAN is a concept by which we can break a big broadcast domain into smaller broadcast domain. VLAN is a concept by which we can control, like these two devices can communicate to each other and these two devices cannot communicate to each other. Basically, just put one port in one VLAN, put one port in another VLAN, and they will not be able to communicate to each other. Already, you must have heard about it, like in CCNA or in your production environment. So, layer 2 ports. A switch port on a switch can either be layer 2 or layer 3. If you are having a layer 2 switch, all the ports that you have on the layer 2 switch will always be a layer 2 port. You cannot make them act as a layer 3 port or routed port, we call them. You cannot make them work on the same. And every layer 2 port will have some VLAN membership. All the layer 2 ports will have some VLAN membership. And you must remember, like clearly, that we have VLAN 1 by default on all the switches. So all the switch ports are part of by default VLAN 1. So all the switches on the layer, all the ports on the layer 2 switch, all the ports on a layer 2 switch all the ports on the layer 2 switch will be the layer 2 ports, and they must be configured with the some VLAN membership. And on the layer 3 switches, on the multi-layer switches, the ports that we have, they can either act as a switching port or they can act as a routing port. We can configure like a port to operate based on the VLAN, or we can configure the ports to operate based on the IP address. Basically, we can convert the port from layer 2 to layer 3 and layer 3 to layer 2. So a switch port on the layer 3 catalyst switch can be configured to operate either as layer 2 or the layer 3 port. Layer 2 port works based on the VLAN membership, and layer 3 port must be configured with some IP address to become fully functional. And there is just one command. Layer 2 port can be changed into the layer 3 port by using the command no switch port under the interface, and layer 3 port can be changed into the layer 2 port by using a simple command switch port under the interface. So we can use the command switch port and no switch port to change the port from layer 3 to layer 2, layer 2 to layer 3. If the port is layer 3, you must configure an IP address on it. If a port is layer 2, then you must configure a VLAN membership on it. Remember that these commands are not available. Of course, these commands are not available on a layer 2 switch, because ports on the layer 2 switch will always remain layer 2 port, and they will always be part of some VLAN. Layer 2 switches cannot have layer 3 ports. We cannot, what I'm trying to say is that on the layer 2 switches, we cannot convert the layer 2 ports into the layer 3 port. We can have loopbacks. I can configure a loopback.
We can do it from port.
That is a different concept, but the port still remains at the layer 2 port. Yeah. So we can, I'm not saying that layer 2 switches cannot have like layer 3 ports, because we can still configure a loopback, interface loopback, one IP address and all. It can have. But a port cannot be converted from layer 3 to layer 2, layer 2 to layer 3. It will always remain as like layer 2 port. Now, how can we verify if the port is layer 2 or layer 3? Just use this simple command. Just go on to the, where is that switch? Just go on to the switch. Just go on to the switch and use the command here. Just go on to the switch Just go on to this switch and see, these are the interfaces available on here. Show IP interface brief. These are the interfaces available. Just use the command show interface Ethernet 0 by 0. And just after that, use the keyword switch port. When we use the command show interface switch port, if you use the command show interface switch port, use the command show interface switch port, and you see that the switch port is enabled. That means this port is a layer 2 port. So this port, this interface name is Ethernet 0 by 0. And since it says that the switch port is enabled, that means it is a layer 2 port, and all the layer 2 ports must be configured with the VLAN membership, and by default VLAN membership is 1. You can also confirm it by the command show VLAN brief. Using the show VLAN brief command, you can confirm that all the ports onto this layer 2 switch, onto this switch is like layer 2 port, and we can see that interface like 0 by 0, 0 by 1, 1 by 0 by 2, and all these interfaces are part of VLAN 1. And since it is a switch that we can configure to act as a layer 3 switch as well, so I can use the command no switch port here as well. The command no switch port is going to convert this interface from layer 2 to layer 3, and confirm it by executing the same command again, show interface Ethernet 0 by 0 and switch port. If you use this command, you will see that it simply says switch port disable, which means that this is a now layer 3 port. And since it is a layer 3 port, you will not see this port in the VLAN table. Ethernet 0 by 0 is no longer there in the VLAN table. Why? A VLAN database. Why? Because that Ethernet 0 by 0 is no longer a switching port. It's now a routed port. So when you use the command switch port, when you use the command show interface is switch port, and you see that the switch port is enabled, then it means it is a layer 2 port. And if you see the switch port is disabled, then it means it is a layer 3 port. Right. Any doubts? Anyone so far? Let me know. Anyone? Any doubts so far? Simple verification related things. No need to worry about rest of the output. Just understand, when we execute this command, if it says switch port enabled, it is a layer 2 port, and the VLAN membership is what? VLAN 1. It says like access mode VLAN 1. That means this port is part of VLAN 1. We can also confirm it by the command show VLAN brief. VLANs we will talk about later. Now, how can this happen? How can this happen that one command is changing the property of, see, on the router we have routed ports, on the switches we have a switching port. Switching ports like that are available on the switch must be configured with the VLAN membership, and a routed port available on the router must be configured with an IP address. How can one command change the property of layer 2 to layer 3, layer 3 to layer 2? We are using just one command, and based on that command, the port is getting changed from layer 2 to layer 3, layer 3 to layer 2. So what exactly is happening in the background? Is it really changing from layer 2 to layer 3, or it is just mimicking it, or it is just like not not what we see actually? So it's not changing the port from layer 2 to layer 3 in reality. What it's doing, understand it. As soon as we change the port, as soon as we go on the interface Ethernet 0 by 0 and we use the command no switch port. This no switch port command gives the switch instruction that the port must be changed from layer 2 to layer 3. Now, what the switch is going to do in the background to make this work, to make that port actually look like it is a layer 3 port, not the real layer 3 port. Real layer 3 ports are there on the routers, not on the layer 2 switch. So what this command is going to do in the background, understand this. This command is going to, first of all, as soon as we execute the no switch port command, immediately the switch is going to create an extended VLAN in the background. Extended VLAN, remember, we have VLANs from 1 to 4094, out of which VLAN 1 to 1005 normal range VLAN, and 1006 to 4094. These are known as the extended range VLAN. So as soon as we use no switch port command, immediately the switch is going to create one extended VLAN, any. So 1006, automatically it will do that, automatically. Either switch can create that extended VLAN in ascending order, means top like 1006, 1007, 8, 9, 10, or it can create that extended range VLAN in the descending order, means start from 4094 and then 4093, 2 and whatever. By default, the method is ascending. Ascending basically means that VLAN 1006, then 7, then 8, then 9, and then so on. So if I have 48 port switch and I use the command no switch port on each and every port, then for every port there will be an extended VLAN 1006, 7, 8, 9, 10, 11, 12, 13, all the way for every 48 ports. So as soon as I use this command no switch port, immediately this switch is going to, in fact, in the background, create an extended range VLAN. It is going to make this port part of that extended range VLAN command. Remember, switch port access VLAN 1006. Just like switch port access VLAN 10, switch port access VLAN 20, 30, just like we use in normal configurations, the switch is going to make this port part of that extended range VLAN. Okay. Third, now whatever it will create a layer 3 interface. It cannot convert the layer 2 into layer 3. It will create a new layer 3 interface for it. Cannot actually convert that interface Ethernet 0x0 into the layer 3 interface because both are two different hardwares. So this actually, for this extended range VLAN that it created in the background, it will create a layer 3 interface for that particular VLAN. Layer 3 interface for a VLAN is known as, remember, switch virtual interface, or called SVI. So basically the switch is going to create SVI for VLAN 1006. Why 1006? Because this is the VLAN that was being used. So layer 3 interface, like it is a switch is going to create a extended range VLAN. Then for it is switch is going to make that interface part of that extended range VLAN. Then it is going to create a layer 3 interface for that extended range VLAN. And then whatever commands we run, whatever IP commands like IP address, OSPF, all the IP related commands that we run, they will actually run on that interface VLAN 1006. It looks like I said interface Ethernet 0x0. It looks like I said no switch port and I'm doing 192.168.10.1. It looks like I'm saying IP OSPF 1. It looks like I'm saying IP access group 101 in. It looks like I am executing all these IP related command directly on the physical interface, but in reality, in the background, all these commands are being executed on that SVI that is created for that interface. However, this thing is not shown to the user. This thing is not shown to the user. User will see only this. User will just see show run interface 80x0. User will just see that, oh, no switch port command is used. That means it is a layer 3 port and every IP related command I can execute on here. But in the backend, this is what is happening in reality.
Can we see that VLAN range in that VLAN range 1006 has been gone off?
Yes, we can see that. And now one more thing. If the VLAN 1006 is being used for this thing, we cannot create VLAN 1006. We can, because it is already being used internally by the switch, so we cannot use this VLAN now.
We
can see that. The command to confirm that this happened exactly the same way. So you can use the command show VLAN internal uses. You can use this command. So what happened actually? What happened that you tried to create VLAN 1006. Okay, you tried to create VLAN 1006. You did not knew about it, let's say, and you tried to create VLAN 1006, right? And you did exit. It just says VLAN not available. and now you're not able to understand what is going on. So it says like, it just simply says here, I tried to create VLAN 1006. I did not know about it. And it says that failed to create 1006. VLAN is not even available in the port manager. Port manager is the component of the switch that manages all the port, VLAN membership, and all those things. So it says that VLAN is not even available on the port manager. Failed to create the extended VLAN. Why? Because 1006 is already being used by Ethernet 0x0. And you don't see any configuration on the interface Ethernet 0x0 regarding the VLAN. And you're not able to understand what is going on in the actually background. Failed to create the VLANs 1006 because it is not available in the port manager. Why? Because it is already being used by Ethernet 0x0. And we are not able to find where exactly. So actually, as soon as you use this command, immediately show VLAN internal uses. Show VLAN internal uses. Here is that VLAN 1006 and interface Ethernet 0x0 is part of that particular VLAN. You cannot actually see that SVIE or anything, but you have to understand that what switch has done in the backend. Switch has mapped that interface with a VLAN, and all the commands, all the IP related commands are now being executed for that VLAN interface, not actually onto that particular switch. And we can change it. VLAN internal allocation policy, we can change either ascending or descending. If you use the descending keyword, it means now if I convert any interface into the no switch port, I configure it with some IP address also. If I do that now you will notice if I change that command, if I use the command VLAN internal allocation policy descending, it means that now show VLAN internal allocation, show VLAN internal uses. Now the VLAN, it will start from 4094 in the reverse order, which is much more better because we use 1006, 7 in we can use those. So now it's better. So this happens in the backend. This happens in the backend. Whenever we execute the command switch port, no switch port, this is what happens in the backend actually. Here, read it. What happens when we use the no switch port command? In the background, the switch reserves a VLAN from the extended range. Like on interface Ethernet 0x0, I said no switch port. So the switch is going to map that interface with the extended range VLAN. Either it could be in the ascending order or it could be in the descending order. Extended range VLAN is from 1006 to 4094, which means that the switch can create any VLAN from this range. However, it goes either in the ascending or descending order based on how we have configured the switch to do so. By default, it will be the ascending order. What it will do, it will bind that physical port with that VLAN logically. You will not be able to see that in the show VLAN brief command. It will not show you that the Ethernet 0x0 has been binded with like 1006. But it will bind that physical port with that VLAN logically. It will not be shown in the VLAN configuration or anywhere in the running configuration. It will just, you can validate it by the command show VLAN internal uses. Once we use this command, you can see that the Ethernet 0x0 has been mapped with the VLAN 1006 and all the IP related commands are being executed onto that SVI, logical SVI. And of course, like if the VLAN is being used by the switch, you cannot create that VLAN by yourself. You get this kind of message that we cannot create this VLAN. One more thing. As soon as you configure the port as layer 3 port, all the layer 2 protocols such as STP, BTP, DTP, they will get disabled onto the port. Of course, like if I have changed this port as a layer 3 port, I have changed this port as a layer 3 port, then of course I do not require STP, BTP because STP, BTP, DTP, these are beneficial for the switching ports. And since we have converted these ports into the routing port, these protocols like STP, BTP, DTP, these overhead protocols will get disabled onto that particular port. Okay. Logically, assume an SVI for that extended range VLAN created in the background, and all the layer 3 commands that we run on the physical interface will run for that switch virtual interface. You don't see it, but it is what it is. You don't see this SVI. You can maximum to maximum validate that extended range VLAN. You don't see that SVI, but it is how it goes like in the backend. And one more thing that you should remember, there is a rule on the router that none of the two interfaces can have same range IP. On the router, if we have two interfaces, we cannot configure same network on those two interfaces. That rule will still be applied here. That means if this interface is part of 192.168.10 network, interfaces, none of the other layer 3 interfaces have the same subnet. So if it is 192.168.10, it should be 192.168.11, 12, 13, 20, 30, whatever. Which also brings up a problem of converting these interfaces from layer 3 to layer 2, layer 2 to layer 3. There is a problem. There is a, not problem, I would say, there is a limitation attached with this command layer 2, layer 3, layer 3, layer 2. We'll talk about it. And one more thing, if you change the port layer 3, all the configurations will wipe. Remember? So if you, for example, you did all these configurations, see, you did all these configuration on here. If I convert the port back into the layer 2 port, right? If I convert the port back into the layer 2 port and you check show run interface is 0 by 0, all the configurations are gone. And if I change it again to the layer 3 port, those configurations will not be there. So whenever we change the port from layer 3 to layer 2, layer 2 to layer 3, all the configuration of that port gets wiped up. Remember this used in Ether channel. I will talk about it. I will not explain you why the IP address is gone from the Ether channel. You have to understand, you have to remember this concept that every time you change the port from layer 3 to layer 2, all the configurations of that port will get wiped. So you either take the backup, show run interface, whatever, or just note down the configuration somewhere.
When you make it a sub interface and get it to the then it will be also a backend. It will be
no. Here. No. See, interface Ethernet 0 by 0. Okay, this is no switch port, which is basically this is like no switch port, which is means like it is a layer 3 port. Now interface is 0 by 0.1, and then what like IP address, interface Ethernet 0 by 0 IP address. It says configuring IP address on the LAN sub interface is only allowed if that sub interface is part of some VLAN. So looks like that concept that we have on the router, that if we want to configure sub interface, we must configure that sub interface with some VLAN membership. So anyway, same thing. So if since we are configuring that sub interface with some VLAN, so it's kind of same. So this is how like
so SCIE और ये इंटरफेस में हमने सब इंटरफेस क्रिएट करके आईपी दिया हुआ है, तो उसमें दोनों में कोई डिफरेंस रहेगा क्या?
Yes, in now SVI, like if you use like no switch port command, this is a different thing. Here the VLAN membership gets assigned like automatically, and so and like those things happen automatically. And when we talk about like this thing like here which is like interface Ethernet 0 by 0, and this thing here we configure the VLAN membership by ourselves, right? So in one case like you can say that the VLAN membership gets assigned like automatically, and like and in one case like we need to manually configure it.
Okay.
Which actually brings me to the next point actually, that what is the drawback of this technique? What is the drawback of converting the layer 2 to layer 3, layer 3 to layer 2? What is like a limitation that we have of converting the layer 2 interface into the layer 3 and layer 3 interface into the layer 2 interface? So let's say now we have a few set of users. Let's say we have some users that are part of 192.168.10, 192.168.20. Let's say these two users, understand it, these two users, they belong to the same department. These two users belong to the same department. These two users wanted to communicate to each other and also wanted to communicate with the switch. These two users wanted to communicate to each other and also wanted to communicate with the switch and maybe the rest of the network. How are you going to make this happen? Think about it. Let me, I guess, 192.168.15. 192.168.15.100. So how are you going to make this happen? How are you going to make this like 192.168.10 subnet and these two into 192.168.20 subnet? It's simple. Like we can go like interface, we can configure the IP here, configure the IP here, but configure the IP here, configure the IP here. But actually, what about the switch? You will require to configure an IP address on the switch. That IP address must be from 192.168.10 subnet and 192.168.20 subnet. How can you make it happen? I just now said, right now I said that if this interface you have converted into the layer 3 interface, whatever IP we configure it here, we cannot have the same IP on the other interface. That means if we have configured 192.168.10.1 here, we cannot now configure 192.168.10.2. Why? Because this is a layer 3 interface, this is a layer 3 interface, and no two layer 3 interfaces can have the same subnet IP address. Which means, technically speaking, we cannot place these two devices into the same subnet. If it is 192.168.10, 10.1, 10.2, you cannot make it like 10.3 and 10.4. You cannot do that. Using the no switch port command, it will just not allow you to do that, because as soon as you use the no switch port command, it basically means like the interface has become the layer 3 interface and no layer 3 interfaces can have the same subnet IP. So maybe what you can do, these are two PCs that you want to connect into the same network. Connect them with a switch here, connect them with a switch and connect that switch with this switch and make this interface Ethernet 0x0 as the layer 3 interface and configure the IP address 192.168.10.1. So this is what 10.2, 10.3 and this is what 10.1. So now they can communicate to each other and they can also communicate to the switch, which is not a good idea from the design point of view. It will layer 2. You have to make it layer 2 because when you make it layer 2, this is VLAN 1, VLAN 1, VLAN 1. It's all VLAN 1, so that they can send the traffic from it. Exactly. It is. We are basically unnecessarily using one extra switch. And why? Just so we can connect like multiple devices into the same subnet, into the same network. We could have used the 48 ports that we have available onto this switch itself. But since the conditions were there, something like that, the conditions were to use, the terms and conditions were to use these two devices into the same network, which we cannot do by making these interfaces changing into the layer 3 interface. So if you don't want to do this, you have one more option actually. If you don't want to do this, you have like one more option for this purpose. See, what happens when we configure commands such as like switch port, no switch port, what happens that the switch creates a VLAN, an SPI in the background. Why don't we do that by ourselves? I know that these two interfaces are part of VLAN 1. Why don't I configure myself? I myself configure interface VLAN 1 and then configure it with some IP address. So it could be like whatever things switch is doing in the background, I can do it with the configuration commands as well. So instead of changing the port into the layer 3 port, it's a good idea to not change that port into the layer 3, but just configure an SVIE by yourself for that particular VLAN. That could also be an option. So we have the option either port. We have an option to either first we have one option to change the port actually from layer 3 to layer 2, layer 2 to layer 3. Otherwise, what we can do, don't change it. Don't change the port into the layer 3 port. So just do this. Just go to the switch. Just go to the switch and just do this. Enable, configure terminal, interface, Ethernet 0 by 0, 0 by 1. I will let them remain. I will let them remain layer 2 port. These ports are layer 2 ports. These ports are no longer layer 3 ports. Right? These ports are layer 2 ports, and I'm going to additionally, I'm going to make them part of VLAN 10. So that there is a separation between the ports that we have here and between the ports that we have here. So I'm going to make these port part of VLAN 10, and I'm going to make this port part of VLAN 20 maybe. So I'm going to say switch port access VLAN 10. If VLAN does not exist and you try to create that VLAN, it will automatically create that VLAN for you. So show IP interface brief, interface Ethernet 0 by 0, interface Ethernet 0 by 1, show run interface Ethernet 0 by 0, show run interface Ethernet 0 by 1. These two ports are simple layer 2 ports and they are part of VLAN 10. Now I can go interface VLAN 10 and I can configure an IP address 192.168.10. maybe 100, whatever. And remember that in this EVNG platform, you also have to do no shut for that SVI. In real, you might not require to do so, but here you need to do that. You need to execute that no shut command. So instead of converting this interface into the layer 3 interface, instead of converting these interfaces into the layer 3 interface and getting stuck on the point that we cannot now configure the same range IP on here, instead of doing that, we can just make that interface part of a certain VLAN and ourselves we can configure SVI. And now I can go on the PC, this host machine. I can say here, I can go on to this PC and I can execute the command here. Here I'm going to say interface IP address 192.168.10 and no shut. This is a router. This device is a router, basic router. So I just went on the interface Ethernet 0 by 0 and I configured it with some IP address. I went on this host number 5 and I said interface is 0 by 0 and I configured it with the IP address. So now we have 192.168.10.4, 192.168.10.5 and an SVI for VLAN 10 192.168.10.100. So I did not configure the IP address on one interface. In fact, I configured the IP for the whole broadcast domain. I configured the one VLAN means one broadcast domain. So I did not configure the IP address. I did not configure the IP address for one interface onto this switch. Instead of that, I configured the IP address for the entire VLAN onto the device. I configured the IP address for the entire broadcast domain of VLAN 10 onto that particular device. So anyone that is part of now VLAN 10 can ping, trace, do whatever it wants to do with the switch actually. So I can go on this host machine and I can say ping 192.168.10.5 and ping 192.168.10.100. So do ping 192.168. So I'm not only able to ping to the host to host, but I can also ping from host to the switch. I can go on the route number 5 and from here also I can do the same 192.168.10.4 and I can ping 10.100 as well. So let's say there are hundreds of, not 100 actually, let's say there are 20, 25, 30 number of devices all wants to communicate to each other and all wants to communicate to the switch as well. So instead of configuring all those 30 ports into the layer 3 port and dedicate a different subnet for each port, I can just make those 30 port part of one VLAN, and I can configure that SVI for that VLAN and configure all the IP and all those things on there. So all these 30 devices will be able to communicate to each other, and they will also be able to communicate with the switch with the help of that switch virtual interface. So what is an SVI? SVI is a logical interface that we create on the switch for a particular VLAN. SVI, switch virtual interface, is a layer 3 interface that we configure on the switch for a particular VLAN. Again, repeating, what you need to do, go to the switch number 1, create a VLAN, then make the interfaces part of that VLAN. So I configured a VLAN 20 and I made these two interfaces part of the VLAN 20. And then I'm going to say interface VLAN IP address 192.168.20 and then no shut. So now these two interfaces are part of VLAN 20 broadcast domain, and for the VLAN 20 broadcast domain, I have configured an IP address onto our switch. I did not configure the IP for one interface. In fact, I configured the IP address for the entire broadcast domain. 15.2, 15 point something is the show version. If you use 15.2 is there. And now, do not forget that logically speaking, here this is one broadcast domain right here, and here is the another broadcast domain. So do not forget to make these two machines. Do not forget to configure the IP address on these two machines. So I'm going to go here and I'm going to say I'm going to configure them with the IP address as well. So one thing that should be very clear from this configuration, that SVI is a different concept and configuring no switch port command onto the interface is a different concept. No switch port is directly going to configure the interface as a layer 3 interface. However, in SVI, not directly, but in a way, we are doing the same thing. The interface, I configured a VLAN membership onto that interface. Then I configured an SVI for that interface, and then I configured the IP address onto that SVI. So indirectly, I configured the IP address on this port, and I configured the same IP address on this port. Why? Because these two ports belong to VLAN 20, and for VLAN 20, I have configured a dedicated IP address. Any doubts so far? Anyone? Let me know. You can confirm that we can ping from host 9 to switch 192.168.20.100. We can ping from host 9 to a switch IP address 192.168.20.100, and we should be able to ping to the machine as well, to the next machine as well. So interface Ethernet 0/0 IP address. Oh, sorry. No, IP incorrectly configured कर दिया. So this interface actually IP address 192.168.20. It should not be 100 actually. It should be 10. So now if I ping, it should be successful. So same thing that you did here, same thing you are doing here. Right, so it is just one broadcast domain, just the second broadcast domain. I configured these broadcast domain by myself. I configured the SVIs by myself. I configured the IP addresses onto that SVI by myself. So instead of configuring the IP on the interfaces, I can configure the IP in an entire broadcast domain, for the entire broadcast domain. This is what we refer to as an SVI. So here, if you don't have the layer 3 switch, then how are you going to give the IP address to the switch? Let's say we have a layer 2 switch. On the layer 2 switch, we cannot use the command no switch port. But we still want to configure an IP address onto the switch. Why? So that we can do telnet, so that we can do SSH, so that we can configure the services such as DHCP, so that we can take the remote access and everything of the device and everything. So in the layer 2 switches, we don't have the option. In the layer 2 switches, we do not have the facility to actually change the port from layer 3 to layer 2, layer 2 to layer 3. So on the layer 2 ports specifically, what we can do, we can manually assign the port to a VLAN, create an SVI, and give SVI and the IP address. That will be enough. So SVI is a virtual layer 3 interface for the VLAN that is configured with some IP address. It allows easier switch management, as we can take telnet and SSH access of the switch using that particular IP. So basically, SVI is a concept. SVI is a layer 3 interface for the VLAN. SVI is a layer 3 interface for a particular VLAN. Layer 3 interface. VLAN is a layer 2 concept. VLAN we use to break the broadcast domain into multiple broadcast domain. VLAN is a layer 2 concept. We create the VLAN to perform segmentation as layer 2. But when it comes to SVI, SVI is a layer 3 concept. SVI for that VLAN basically means an interface for that particular VLAN. SVI is a virtual layer 3 interface for a dedicated VLAN. It must be configured with some IP address, and that IP address must belong to the same subnet as the host machines. So if the users in the VLAN belong to 192.168.10 network, that SVI must also be configured in the same 192.168.10 network. In some network, VLAN 1 can be used for the same purpose. Like as all the ports are part of the VLAN 1, I can just simply configure interface VLAN 1 and configure with some IP address. Because on all the switches, because on these Cisco switches, by default, the VLAN membership is 1. So I can just configure an SVI for VLAN 1. I say interface VLAN 1, configure it with the IP address, do the no shut, and whatever IP we have given, 192.168.12, whatever IP address we have given to that SVI, same subnet IP I will configure on all the machines, and they will be able to communicate with the switch using that IP address. They will be able to take the SSH and all those things. However, it's never advised to use VLAN 1 default VLAN for any purpose, because it imposes a security risk. Everyone knows that by default VLAN is VLAN 1. So attacker will come, and the attacker will just connect itself. Attacker is going to connect itself onto a port that is part of VLAN 1 and just try to access your switch, try to perform different types of attack onto the switch. So this could create a security challenge as well. So we consider using some other VLAN as the management VLAN in our network. VLAN 900, 911, 999. We configure random VLANs as the management VLAN in the network. SVIs can be created on both layer 2 switch, layer 3 switch, and can act as the gateway for the users in case of inter-VLAN routing. So now here, right here, in this diagram, in this topology, here we have SVI for VLAN 10, here we have SVI for VLAN 20, SVI for VLAN 10 and SVI for VLAN 20. Here are two users that have 192.168.10.4 and 10.5 IP respectively. Here are two users, IP address 192.168.20.10 and 20.9 respectively. Here we have 192.168.10.100 and 192.168.20.100. If you remember the inter-VLAN routing I just need to use one more command, and right here your inter-VLAN routing is done. I just need to go on to this switch and enable what? One command, IP routing, and your inter-VLAN routing is done, which we'll talk about later. But these SVIs can also act as the default gateway for the clients, so that the client will send all the traffic to the SVI. The client will send all the traffic to the gateway, and from gateway it will get routed from one broadcast domain to the other broadcast domain. Why? Because routing is now enabled. So these SVIs can act as these switch virtual interfaces can act as the default gateway for the VLANs, so that their traffic can be routed from one network to the other network, which is a very commonly seen deployment in the inter-VLAN routing. We generally do not use we use switches as the gateway for our end users. We can also use routers as a gateway. We can configure sub interfaces on the router and mark them as the gateway on the client. But using like switch is much more better idea in this case. So these SVIs, the SVIs that we have created on the switch can actually act as the default gateway for the user in case of inter-VLAN routing. Is anyone facing any challenge in the voice? For anyone like voice is not clear, confirm once. Is it okay? Just confirm once, guys. Like
yes, it is okay.
Kulvinder, you can like rejoin once. Might be some browser level issue. Try to join it with with other browser or the mobile application. Try to see if that's a problem. Kulvinder, try that once. Okay. So we can configure SVIs on the switches so that our broadcast domain can be configured with the IP address, and we can send the traffic, receive the traffic based on the same. Do not get confused with the concept of SVI with the concept of loopback. So there are three types of interfaces onto the switch. We have physical interface, we have SVI, and we can also have some loopback interfaces, which are like other interfaces. Loopbacks are not equal to SVI. SVI is not equal to loopback. SVI is a different concept. Loopback is a different concept. On a router, typically we have a layer 3 interface and we have a loopback interface maximum. Until we use that router for the inter-VLAN routing, we are not going to have a layer 2 interface onto the router. But other than that, if you talk about like from the switching point of view, on the switch we have total, if you think there are total three types of interfaces. That we have a physical interface that we can see, and there are some interfaces that we cannot see, such as SVI, such as loopback. So remember, whenever we use that command switch port no switch port, this happens in the background. We can use the command show like VLAN internal allocation policy ascending descending to change the order in which those extended range VLANs will be created. You can do that. So if you use the command descending, that means the VLANs will be created from 4094, 93, 92, and then so on, something like that. So either you convert the port, either you convert the interface. One more thing, the difference between the port and interface. Ideally, like port and interface, they refer to the same things. In routing, switching environment, we don't, we use the term port and interface synonymously. In our routing and switching environment, we use this concept of port and interface synonymously. We call port as interface, we call interface as a port, which is not a problem. It's okay. We can call the port as interface as a port in routing and switching environment. That's okay. However, when it comes to port, we have console port, we have auxiliary port. Those are ports. The rest are interfaces. On the switch, we have switch port. But like in routing and switching, it's all like synonymous. Like we can use the term port and interface synonymously. No one is going to like interrupt you that okay, why are you using this term? But when things go to the wireless, the port and interface, they refer to two different things, complete different things. So someday when you cover wireless, just remember that the term port and the term interface might refer to two complete different concepts. We have like physical ports on there, then we have like interfaces, like those logical interface that the WLC automatically creates in the background to map the physical interface. Like, you know, we have, for example, on our WLC, we have a port called redundancy port that is used for the HA, high availability. That is a port, that is not an interface, right? On our WLC, we have a management port, MP, we have RP, like we have those physical ports that we can see. And in the backend, that management port is going to be mapped with an interface. So that these are two different concepts there. For example, in our WLC, in our wireless environment, we can create a SSID. That SSID we can map with an interface, not a port. These are two different things. So in the wireless terminology, things go here and there a little bit different. But in routing and switching here, like the things are going to be synonymous. No one is going to like say anything about the same. But in wireless, you might see here and there a few different concepts. Anyway, so yeah, this is done. This is it. This is all that we need to talk about. Any questions, anyone? If you have, let me know. Any doubts, anyone so far? If you guys have any doubts, let me know.
Sir, if I consume all the VLANs, means if I configure all the VLANs in database, then can I make the L2 port to L3 then? Means as
okay, let's do that. Okay. I will answer that question like when we talk about VLAN, because it involves a concept of VLAN. I'm going to leave this with a question. Actually, I'm going to answer this with a question. The question is, how many number of VLANs we can create on a switch? There is a question. The question is that how many number of VLANs we can create on a switch? Is there any limit of VLANs that we can create on the switch?
In 4094, no, 1 to 4094.
That is the total range of the VLAN, right? How many number of VLANs are supported onto the switch platforms locally? Is there any different limit for the same? Because if I create all the 4000 number of VLANs onto the switch, my resources, these layer 2, layer 3 switches that we have, these resources might get like overrun. So is there any, just to read for the moment, that is there any limit that how many number of VLANs we can configure? Like we have the support for those 4094, right? We can configure like VLANs from like 0 to 4094, 1 to 4094. But how many number of VLANs we can actually create, including the extended range VLANs? And which, if you come to know the answer of it, you will almost get your answer to the question. But we will discuss this in our VLAN section. When we talk about VLAN, then I will definitely answer this question. This has something to do with the number of VLANs that we can create onto the switch platform. Yes, by default, we can create from 2 to 1001, but that might also not be true if we have like those layer 3 switches 92, 93. We will see things about the VLAN in our upcoming classes, then most probably the next class. But for the moment, the question that you put, that if I create all the VLANs, on the switch, if the maybe the extended range VLAN is not available to convert the port from layer 2 to layer 3, will we be able to still convert the port from layer 2 to layer 3, or will we get that kind of error that VLAN not available, cannot convert it, something like that? We will definitely answer this question in the VLAN class. But it has something to do, just to give you a small idea, it has something to do with how many number of VLANs we can create on the switch locally. It's not, I'm not saying that how many number of VLANs like we can create, it's like how many number of VLANs are supported to be created onto the switch locally, like that. We will definitely look into it on the VLAN class.
Okay, thanks.
Right. So this is done. This is like you should now be completely clear that we can either convert the interface from layer 2 to layer 3, or we can simply configure an SVI, which is much more easier approach. And anyone who have gone through the SDA classes, any of you who has gone through the SDA class, you should remember, when we push the configuration from the DNS center, the switch port does not get changed from layer 2 to layer 3. Switch creates the VLAN. It configures the port part of that VLAN and it creates the SVI for that VLAN. Switch also performs exact same thing that we just did right here in case of software defined networking. To anyone like who have not covered this, when you cover the SDA classes, you will get more idea about it. But this is what I'm trying to say. This is much better approach than converting the port directly into the layer 3. It allows you to have multiple users in the same broadcast domain. They will be able to communicate to each other, and they will also be able to communicate with the switch. On the other hand, if you convert the port from layer 2 to layer 3, every layer 3 port will have a different subnet, which might not be your requirement. So based on the things that we discussed today, either you are going to use the no switch port command. So where the no switch port command is beneficial then? Where should we use the no switch port command? Let's say, for example, we have this switch and the switch is going towards a router. And we need to configure the IP address. We need to configure the IP address. We need to perform routing based on EI, GRP, OSPF also. Then it's good. It's okay that you convert this interface into the layer 3 interface and then configure the IP address and everything. Like, upstream interfaces, you can upstream interfaces, upstream port, you can convert into the layer 3 interface configured with the IP address, then configure EI, GRP, OSPF neighborship, exchange the route, ping pong, and everything will work. But the interface is going towards the user. Ideally, you should not, or we don't change it into the layer 3 interface. We will let them layer 2 interfaces just configure the SPI for the same. So I have a few questions then that you will find the answers and keep the answers with you until others discover the same. So every interface that is a layer 3 interface will have a MAC address, na? Every interface that is a layer 3 interface, every interface where we can configure the IP address will always have a MAC address, right? Interface C, this is the host machine. Show interface Ethernet 0x0. Right here is the MAC address of that interface. We can use the command show interface Ethernet 0x0 pipe include BIA, burn-in address, so that we see just the MAC address. What I'm trying to say is that every layer 3 interface has a MAC address. Every layer 3 interface, every interface basically has a Ethernet. Already discussed in the previous classes that Ethernet interface will have a MAC address. So when we convert the port from layer 2 to layer 3, switch port, no switch port, it's okay. If we convert the port from layer 2 to layer 3, it's okay. That interface show interface each 0x0 pipe include BIA. The interface has this MAC address. This MAC address will be used for the communication purpose. If I convert the interface from layer 2 to layer 3, this interface can be used. This MAC address can be used. But what about the SVI? What is this? Oh, sorry. How it got this MAC address? This is a virtual interface, na? This SVI is a complete virtual interface. How did it get the MAC address? From where it got the MAC address? And how it got the MAC address? Why I see these two MAC address, like why do I see these two MAC address as exactly the same? Exactly the same, na? AABBC 801000 801000. Why do I see them exactly as the same? Why it is not creating any problem? Because if we have like same MAC address on two devices, then it will be a problem. So first question, how SVIs get the MAC address? Okay. Second question, can two or more SVIs have the same MAC address? Third question, if two or more SVI have the same MAC address, will it create any problem or not?
First of all, your IP address
वो
MAC address लेता होगा.
No. For VLAN 10, we have one subnet. For VLAN 20, we have a different subnet. Right. So this MAC address actually has nothing to do with the IP address. There is some different mechanism. You need to find that out. There is a different process. There is a different mechanism that the switch uses to get the MAC address, to configure the MAC address on the SVI. So just try to find out from where it gets the MAC address. Of course, like I'm not going to answer it. You can show interface VLAN 10. You can see this has the MAC address, and you can see both the SVI. You configure multiple SVIs. Every SVI will have the MAC address. So first question, from where this MAC address actually came. Second question, why I'm saying these two MAC address exactly as the same. Third, is there any problem if two or more SVIs have the same MAC address? Because in this simulated environment, I don't see any problem. Is there any problem if these two devices have the same MAC address? Will it create any problem in inter-VLAN routing or so? Try to find the answers to these questions. Can we create more than one SVI on a layer 2 switch? More than one SVI onto the layer 2 switch. If we have a layer 2 switch, in the layer 2 switch we have 24 port. We have decided 12 port part of VLAN 10, and we have decided the rest of the 12 port part of VLAN 20. And we want VLAN 10 users should be able to communicate to each other and should be able to communicate with the switch as well. I want the rest of the 10 users, rest of the 12 users they are part of VLAN 20, and they should be able to communicate with the switch as well. Same exact thing. So I need to go on to the switch and configure two SVIs, SVI for VLAN 10 and SVI for VLAN 20. SVI for VLAN 10 will allow these switches to talk to these users to talk to the switch, and SVI for VLAN 20 will allow for the same. Now the question is, can we really create more than one SVI onto a layer 2 switch? Is it possible? Anyway, so a lot of questions. Try to find the answers to these because these will not be addressed or answered in the class. So first you try to find that out. If by the time when the class ends, if you guys still will remember these questions, then we will discuss at the very end of the classes. But for the moment, try to find out the answers to these questions, because these might be beneficial when we perform routing, when we are doing the troubleshooting. A few things like these might be beneficial. So read about it. Okay, so this is like SVI concept. This is like the layer 2, layer 3 switch concept. Now, we have connected this switch. I'm going to actually, in fact here, I'm going to connect this switch with another switch. So this is one switch. I'm going to connect it with another switch. Now actually I cannot connect this switch while the device is powered on. So what I need to do actually, I need to power this off, and then I need to connect it. Remember, this is how EVNG community edition actually works. And see, on the switch number 1 we don't have ports. On the switch number 1 we have only 4 ports, and all the 4 ports are being used. So we don't have more ports on this switch. So what you can do, edit and configure more port from here. So if you say 2, like Ethernet port group 2 means 8 port, 1 means 4 port, 2 means 8 port, like so, something like that. And now we will have those additional ports. So we can edit the switch to add more ports onto the switch platform. So I have connected the devices like that. I have connected these switch with the upstream switch, and the link that we have is Ethernet 1/0 to Ethernet 0/0. This is like, if I say this is like configure terminal, host name, I'm going to call it DSW1, something like that. Now, in Cisco devices or in normal devices as well, let's say, for example, we are given the telnet or SSH access of one of the device, and I really have no idea of the rest of the topology. I don't have the idea of the rest of the network. I just have the access to this switch. I just have access to this switch, and I don't have the idea about the rest of the network. So we are given the option in Cisco devices, in non-Cisco devices, we are given the option to use a protocol that called Cisco Discovery Protocol, or CDP, and a protocol called LLDP, Link Layer Discovery Protocol. So these protocols such as CDP and LLDP, these are used for device discovery purpose. We use this protocol for the device discovery purpose. By default on Cisco devices, CDP is by default running. LLDP does not run by default. We can enable the LLDP if we want, but Cisco Discovery Protocol is by default running on the Cisco devices. What is the purpose of CDP and LLDP protocol? The purpose of Cisco Discovery Protocol and Link Layer Discovery Protocol, it is to discover the neighboring devices of the switch, router, firewall, access point, and any other appliance. So if you have the access to switch number 1 and you want to see all the directly connected devices associated with that, you can use the command show CDP neighbor. Remember that this command is going to show you only and only directly connected neighbor information only when those neighboring devices support CDP or LLDP. So show CDP neighbors, this command, in brief, in a table format, in brief, it is giving us the information that we have a device host 10, we have a device switch host 9, host 5, this actually connected onto the switch number 1. This is connected on our interface 0/3. This is connected on our interface 1/0. Local means my interface, and port ID means remote, neighboring device interface. So these devices are exchanging CDP messages to each other, and in that CDP message they are able to know variety of information. They have like the option to know variety of information on there. Variety of information is actually being exchanged with the help of this CDP protocol. Information such as this. What is my interface? Going towards which device, which interface. So my interface Ethernet 0/3 is going towards host number 10, interface Ethernet 0/0, and it is a Linux based actually device which has routing enabled, which has B, stands for bridge capabilities enabled, whatever it is. So here it lists device ID, local interface, capability, platform, and the port ID. This output is beneficial to you to know about all the directly connected neighbor information of the switch, router, firewall, WLC, platform. Once the devices exchange the CDP message, the information will be maintained in this table, and this information is valid for 180 seconds. So once the information is maintained in the table, this information is now valid for 180 seconds. And in every 60 seconds, CDP messages are sent out of every CDP enabled interface. So all the devices will keep exchanging the CDP messages. So this timer will never run out. Now, earlier, this switch name was switch. So device maintained that information. And since now I changed the device name from switch to DSW1, the updated information was maintained, but this information will go away after 180 seconds only. So if there is an entry in the table, that entry will be flushed after a total time period of 180 seconds. So you refresh it again, you can refresh it again, you can see the timer. Just keep a look at this timer. 134, 130, 129, 127, 126, 124, 123, 122, 120, 179. So timer started from 180, 179, 178, 177. It kept going on and on. And as soon as 60 seconds happen, as soon as 60 seconds pass, the device will again receive the CDP message and it will refresh that particular time, so that this entry will never age out. Like in every 60 seconds, we are receiving the CDP message, so that these entries, they never age out. If I suddenly stop receiving the CDP message from this device, then this entry will age out, but after 180 seconds only. The entries will be maintained in this table for 180 seconds. Otherwise, use the command clear CDP counter, clear CDP table. You can use these commands to clear the CDP table, show CDP neighbor. Now you don't see anything. Command is clear CDP table, clear CDP counter. Clear CDP counter basically means how many number of CDP messages were sent, receive that counter. We are clearing it. And clear CDP table command means that I am clearing the CDP table. So if I use the command show CDP neighbor, every entry is gone. And now when I receive the CDP message for the next time, then these entries are again going to be maintained. So just wait for, see, one is there. Now just wait for the other devices to send the CDP, again is there. These are routers. They can send the CDP message. So their entries are actually available. Again, a device is there. Again, a device is there. So every time I receive the message from the neighboring device, I will keep the information in my table. This command is very handy to find out your which interface is going towards which neighboring device. What is that device? That is a device where we have enabled the routing capabilities, where we have enabled the switching capabilities, that is also supportive of IGMP protocol. And you can always use the keyword show CDP neighbor detail. If you want to take the information in very detail, you can use the keyword show CDP neighbor detail, and it will list you, it will give you the information about all the CDP devices in detail. See, this is the first device. The first device name is what? Host number 10. What is the IP address of that device? If it was a real router, I would have seen the platform like 1841, which platform router it is. I can also see that. If it was a real device, I would have seen the platform of that device. I can see the capability. I can see my interface. I can see the remote interface, hold time, software version, advertisement version, duplex, management IP. I can see this much amount of detail in our Cisco Discovery protocol if I use the keyword detail after it. And each and every device information will be shown in very much detail if you use the command show CDP neighbor detail. Also, show CDP neighbor detail, and if you don't, if show CDP neighbors on interface Ethernet 0x0, 0x0 detail. If you want to see the information in only on one interface, you can always use the keyword show CDP neighbor and show me the information only on one interface. That is Ethernet 0x0. So this command basically means that show me the CDP related information only on one interface and only on one interface in very much detail. So I can always filter out like the output as per our requirement. So show CDP neighbor on the interface, and show CDP neighbor detail command we can actually use. Okay. Now I can enable disable the CDP. Let's say I do not want to process. If you want to enable disable CDP, For everyone, just use the command cdp run. This command will enable the CDP, and no CDP run. This command will disable the Cisco discovery protocol. So if you want to enable the CDP, the command is CDP run, and if you use the command no CDP run, that means the CDP has been now disabled. This is global level. At the global level, we can configure like I want to enable or disable CDP. I can also do this for particular interface. Maybe our interface is going towards the service provider router, and I want to disable CDP on there. So interface is 1/0, and I can say CDP enable, or I can say no CDP enable. So in the global configuration, the command is CDP run, and in the interface configuration, the command is CDP enable or no CDP enable. CDP enable or no CDP enable command is going to enable or disable the CDP on per interface basis, and the CDP run command, no CDP run command, will enable disable CDP at the global level. CDP is a Cisco proprietary protocol. That's why we also have an open standard protocol. Let's assume that the neighboring device is not a CDP device. Let's say that the neighboring device is a Juniper router, Juniper device that actually does not support CDP. So I'm going to go on here and I'm going to say configure terminal, no CDP run, and clear CDP table so that all the previous entries get cleared. So let's say this is a device that does not even support the Cisco discovery protocol. We can always enable LLDP run or no LLDP run. Same syntax, just use the keyword LLDP instead of this CDP. So either you can enable LLDP run or no LLDP run on the global configuration mode. That means enable LLDP on all the interfaces. But if you want to enable on a specific interface, just go on to that specific interface and LLDP. In LLDP, we have the option to control both of the things. Are we going to transmit the LLDP message? LLDP receive. This is equal to CDP enable. In CDP, we don't have the option to control this. If we enable or disable the CDP on the interface, it will either enable or disable CDP onto the interface. We cannot control that. I want to send the CDP message but not receive it. In LLDP, it is possible that we can control both transmit and receive. So this command basically means that only onto that interface I'm going to transmit and I'm going to receive the LLDP message. But I could have also said only transmit, don't receive, or only receive but don't transmit. So if let's say a device does not support like CDP, we can use the open standard protocol called LLDP, and it will give you, I would say, much better information as compared to CDP. Like LLDP includes a lot more information as compared to CDP. A lot more information, POV and everything. If you use the command again is exactly the same. Show LLDP neighbor. Show LLDP neighbor detail. We can configure like show LLDP neighbor detail. We can run the command show LLDP neighbor and LLDP. First of all, we need to enable LLDP and then we can enable disable on the per interface basis. So LLDP run. Now see, show LLDP neighbor. Let's observe it. Let's wait for the LLDP messages are sent in every 30 seconds and the whole time is 120 seconds. CDP messages are sent in every 60, 180 for CDP and 30 and 120 is for the LLDP. 30, 120, I guess. 120 is correct. 30, 120 is there. If I remember correctly, do cross check it from like, some sources. But I believe 30, 120 is there. 30 seconds, in every 30 seconds, LLDP messages will pass and 120 seconds is the hold time. What I'm trying to say, LLDP actually gives you much more information as compared to CDP. What do I mean by that? If you use the command show CDP neighbor on an interface like Ethernet 1/0 detail, just take a look at this output, okay? And just take a look at this output. Just take a look at these two outputs. In the CDP output, what we have the name of the neighboring device, we have the IP address of the neighboring device, we have what capabilities are enabled onto that device, right? What platform is there, what is the remote interface, what is my interface and what is the remote interface, the whole time, software version, duplex, management IP, and that's it. However, if you take a look at this information that LLDP displays you, it says the local interface, in fact the chassis number of the neighboring device is also there, the port number, description, system name, software version, how many capabilities are supported and how many capabilities are currently enabled, two different things. That information is there. Auto negotiation, management address is not being advertised, VLAN ID is not being advertised, media attachment unit, physical media capabilities. These are extra information that is still not being advertised by the neighboring device, but we have the option to advertise these additional information as well. This information is referred to as TLV. TLV stands for type, length, value, whatever is spelling. So type, length, value, TLV. What is TLV? Every time we hear this word like TLV a lot. So what is TLV? TLV is the format in which the information is carried in this CDP, in these LLDP message. So type, length and value. For example, type, local interface number. This is the information that we want to carry. This is a type of information that I want to carry, that I want to send, that I want to receive to the neighboring device. So T stands for the type of the information that is being carried, that is being received from the neighboring device. Length means size and value means value, such as system name. System name is a type of information that we want to exchange. Whatever is length of that information, and value is going to be DSW1. So the information in this CDP and LLDP is exchanged in the format of this thing called TLV. TLV stands for type, length and value. Type specifies the type of information that we want to exchange, value specifies the value of it, and length basically means the size of that information. In LLDP, we have the option in LLDP, configure terminal, LLDP, the very last option, TLV select. We can advertise these additional information, or we can control that I don't want to advertise these additional information. Power management. I want the LLDP to advertise POV capabilities. I want it to advertise the system description, just in case if we have set. I want it to advertise the port VLAN. I want it to advertise the port description. These are additional, these are the information that our LLDP protocol can carry in the message. And what do we have in the CDP? Here we do have, in CDP also we have some TLV. In CDP, here this is called TLV. This is called TLV, such as IP address is a type of information that we want to carry. The size of the IP is 32-bit length and the value is 192.168.10.4. So CDP, LLDP both carry the information in the format of TLV. But what information can be carried? This is quite different. In CDP also, we have the option CDP, TLV, select, TLV list, TLV, and we have only two things. Whatever are these things? We have only two options when it comes to like additional information that we want to send to the neighbor router in CDP, but we have like quite a lot of information in our LLDP that we can actually advertise to the neighbor router. So if I now go on the switch number 1 and use the command show LLDP neighbor detail, we can see like additional info, this much amount of information getting advertised from the neighboring device. Actually, the term B stands for bridge. Bridge means switch. Actually, the term that they use switch in R for router. So B basically means like bridge. This is the difference actually between the CDP and LLDP. In CDP, switching capabilities are represented with the keyword S, and in the LLDP, the switching capabilities are represented with the keyword B. B means bridge, the original implementation that we have. So both of these protocols, in short, and we can control this thing on per port basis. Interface, Ethernet 0x0, LLDP, TLB select, and on per port basis, I can select like I want to advertise the power information. I can control that I want to receive or not receive the LLDP messages. So both of these protocols have the same purpose. Both of these protocols, CDP and LLDP, have the same purpose. CDP and LLDP both, they discover basic information about the routers and switches without needing to know passwords for these neighboring devices. It is a layer 2 protocol. It does not even require that it does not even require IP address to be set on the interface. It just works on layer 2. Interface, if it is up, CDP messages can be sent. It is a pure layer 2 message. So without, like, if I want to know certain type of information of the neighboring device, I don't need to log into that device by entering the passwords or so. I can just use show CDP neighbor detail command. I will be able to get the neighbor interface. I will be able to get the IP address. I will be able to get the VLAN. I will be able to get duplex. I will be able to get a lot of information. To discover the information, routers and switches send the CDP message out of their interface. These messages announce the information. Okay, fine. Same thing here as well. The only difference between the CDP and LLDP is, first of all, the one is proprietary and one is open standard. IEEE standard 802.1 AB. Second, the amount of information that LLDP can carry is actually much more than the information that the CDP can carry.
Can we have that password authentication for that?
No. You cannot have any. Either you can enable or disable the CDP, LLDP on per interface basis. If you don't want to like send your information out of the certain interface, then just disable the CDP on that interface. Not have like any complex or any mechanism.
But my previous device, it's CDP run and hacker inserted that device and
then yes. Yes, so all those kind of interfaces, like where the end users are connected or these devices, you should always disable the CDP. Any interface that is going towards like the provider side or so, you should disable the CDP. Otherwise, there is always a security risk. You can control what information you want to advertise, but you don't want to advertise. But we do not have like any authentication or any that kind of support for these messages. These are just layer 2 messages. They cannot carry like a lot of information. So one is, and they two are not compatible to each other. So you cannot use CDP on one end, LLDP on the other end. You have to have CDP on both ends, and you have to have the LLDP on both the end. Right? Both the protocols can provide certain information about the neighbor. Yeah. So this is all that we need to know from the CDP, LLDP point of view. Just basic protocol. Anyone again who have gone through the SDA classes, they must know the use case of CDP. It is the CDP by which DNS Center discovers the devices into your network. So CDP, LLDP can also be used in the DNS Center nowadays. So CDP, LLDP, these two protocols you should know, because these protocols will be used today, and even when the software defined networking comes into the picture, then also these protocols will be used for the device discovery purpose. Like if we have, because point is that in most of the situations we are having like, see, one advantage of using the LLDP is that it carries a lot of information. Second thing is that in most of the companies, we don't have like a single vendor environment. We have like multi-vendor environment. So LLDP is much more preferred choice. If you have like only Cisco devices, then it makes perfect sense to use protocols such as CDP. But if you have like a mixed environment, it's always a good idea to run either both or just the LLDP. Right, so this is it that we need to talk about. And next topic is campus design. How can we design our campus area network? Basically 2-tier, 3-tier, routed access layer, that. We will talk about that. This campus design, we will talk about that tomorrow.